I'm live right now. Okay. Hello. Am I audible to you?
Yes, sir.
Yes,
Check.
sir.
Can you check quality? Right. Thanks. 1080. Check. Am I audible to you?
Yes,
Hello?
sir.
Am I audible?
Yes, sir.
Okay. So shall we start now?
Yes, sir.
Okay. So today we are going to discuss about you can see this airplane performance like previous year questions. We have already completed these questions I think twice, right? But it's a final touch, or you can say we are going to discuss these all questions one more time. So let's start with our first unit. See what I'm planning in this lecture. Generally, if we talk about this airplane performance, then generally check. Is it visible to you? First, let me know. Is it
Yes,
visible?
sir.
Okay, let me
Yes, sir.
check. Okay. Okay. So generally, we are going to discuss about this airplane performance. So the first part is nothing what you can say the atmosphere, and you can say your instrument part, right? Then second one, you can say we are having airplane performance. Can you check my voice is clear or not? Airplane performance. Now, here we can define this airplane performance in two categories. One, you can say it's a non-accelerated flight. Another one is the accelerated flight, right? So today we are going to discuss about this non-accelerated flight. And along with this, we are going to discuss like previous year questions. So let's start with our first question. Okay, so this is the question which they have asked in GATE 2008. So if you look at the previous year questions, right, from 2007 to 2028, so you should have to segregate all the topics based on, you can say the chapter wise, or if I want to say like some of the students around, you can say 200 plus students have requested like you should have to provide the solution like chapter wise, subject wise, and year wise. So I have so today we are going to discuss these all questions based on, you can say, the subject wise, then topic wise, and you can say the year wise. So first question is that which of the following statement is true as the altitude increases in the stratosphere? So please take care. They are saying the stratosphere of international standard atmosphere. So the first option is the atmosphere increase and dynamic viscosity decrease. Second option, temperature remains constant and pressure increases. Third option, temperature decreased and sound speed decreases. Fourth option here is temperature remains constant and density decreases. So first of all, you should have to know at least about the two layers of the atmosphere. One is what? One is the troposphere, and second one is what? Stratosphere. So what happens in stratosphere? You can say in stratosphere generally, you can say the temperature varies linearly, or you can say there is a decrement of the pressure if the altitude is increases. For example, the temperature at the mean sea level is nothing but you can say 288 Kelvin. But as the aircraft, or you can say as the altitude is increases, then the temperature decreases linearly, right? And at what rate it decreases? It decreases at minus 0.0065 Kelvin per meter, right? That's a lapse rate in the troposphere region. But Then another reason is nothing but you can say that's a stratosphere. So the interface between this troposphere and the stratosphere is generally known as the tropopause, right? Check, am I audible to you?
Yes, sir.
Yes, sir.
Okay, so what is the tropopause? What are the properties at tropopause? Anyone? Or how to calculate these properties? Generally, we are having the relation. If you want to calculate like what is the temperature at in the troposphere region, then generally we have to write this TH equal to T at sea level plus lambda into H, where this lambda is nothing but you can say just a minute. Now, is it visible to you? First, let me know. Is it clearly visible? These options? Hello, am I audible or not?
So it get little blurred.
Okay. Now okay.
Yes, sir.
Okay. So generally what happens in troposphere, we can calculate this TH equal to T at sea level plus lambda into H, right? So what is the value of lambda? This lambda is nothing but you can say simply it's a dt upon dh, right? So that's nothing but you can say it's a lapse rate. So in troposphere, generally this lapse rate is negative and this value is nothing minus 0.0065 Kelvin per meter, right? Now, the next layer is nothing but you can see stratosphere. So as you can see in the initial or you can see in the beginning of this stratosphere region, your temperature remains constant. If the temperature remains constant, if we talk about the lapse rate here, so what is the lapse rate here? Delta is equal to dt upon dh, meaning what? Generally, the temperature remains constant. The temperature remains constant from the altitude of 11 kilometer to 25 kilometer, right? In this region. So if suppose if the change in temperature dt is equal to 0, so what is the lapse rate in this region? 0 only, right? Check. Am I audible? But
Yes,
what
sir.
about the pressure density? This pressure and density is decreases, doesn't matter whether it's a troposphere region or you can say stratosphere region. Agree or not? Can you tell me what is the formula for this density change as well as the pressure change in troposphere as well as in stratosphere? Then you will understand it better. Anyone? Yes, yes, please.
Sir, for constant temperature region or linearly varying?
In troposphere region. Yes.
T2 by T1 equal to T2 by T1 raised to minus G upon AR.
Yeah. So we have taken this A is nothing but you can say left rate. So simply you can write PH upon P means sea level equal to TH upon T means sea level raised power how much? Minus G upon lambda into R. Let me show you. Generally, this relation is nothing but PH upon P at sea level equal to TH upon T sea level raised power how much? Minus G upon lambda into R. Now, if you put the value of G equal to 9.81, how much? 9.81 and lambda equal to minus 0.0065. Then what is the value of this? Yes, obviously, and we are considering this air is what? You can see it's a perfect gas, right? So this R value is nothing but you can say 287 for the air. How to calculate? Just put R equal to RE by M. Consider the value of M is around 29. So ultimately we will get a very near value, or you can say the value very near to 287, right? We have done these all things in class. So this minus G upon lambda R, if you put here, G is minus 9.81 divided by minus 0.0065 into R is nothing but you can say 287. So what is this value? The 5.25
5.256.
86, right? So directly you can write this PH upon PSL is nothing but TH upon PSL raised to 5.2586. Now, another formula we are having for density here. So this rho H upon rho SL is given by TH upon TSL raised power how much? Anyone?
Minus G upon lambda R minus 1.
Minus G upon lambda R plus 1. Check. Right?
सर होल ब्रैकेट में आएगा वो नेगेटिव साइन बाहर.
Yes, sir. Whole bracket.
Yeah, something like this. Now
Yes,
correct?
sir.
So here, if you put the value of G upon lambda R is equal to G is 9.81, lambda is 0.0 minus 0.0065, R is 287. Definitely, how much you will get? You will get this value rho H upon rho SL. So both are same thing now. If I'm writing it's a minus G upon lambda R minus 1, right? So minus G upon lambda R is how much? It's a 5.2586 minus 1. So you will get this value TH upon TSL raised power 5.2586 minus 1. So it leads to the value TH upon TSL raised power 4.2586. Check please. Are you getting this one?
Yes, sir.
Now, if we talk about the another layer, which is nothing but you can see the stratosphere. So what is the formula for that? So in case of the stratosphere, the formula for, you can see the pressure as well as the density is same. Say yes or no, first of all, in the isothermal region of this stratosphere. Are you agree or not?
Yes, sir.
Yes, sir.
So what is the formula? You can simply write rho 2 by rho 1 is equal to P2 by P1 is equal to how much? E raised power, how much? Minus G upon RT in bracket H2 minus H1, right? Please check, please verify. Hello, am I audible
Yes, sir.
or not? So this formula is how much? Rho 2 by rho 1 is equal to P2 by P1 is equal to E raised power minus G upon RTS, right? In bracket how much? T2 minus, sorry, H2 minus H1, right? Please check. Clear? Please respond fast.
Yes, sir.
Ajay, are you there? Shubham, are you there? What's the problem? Jeet, are you there? Archana, Akash, Deepali. Jeet, are you there? Ram, are you there?
Yes, sir.
Shimran, then you should have to
Yes, sir.
respond during the class, okay? I'm conducting this lecture particularly for you, right? So at least you should have to respond. Almost there are 40 to 50 students in the class, right? It's not a recorded lecture. Please be active during the classroom. Otherwise, you can go and watch my previous lectures. Is it okay?
Yes, sir.
Yeah, thank you. So now look here. So this rho 2 by rho 1 is equal to P2 by P1 is equal to E raised power minus D upon RTS into H2 minus H1, right? So one thing is clear. If the altitude is increases, right? If the altitude is increases, then your pressure and density is going to decrease in the stratosphere region. Are you agree? You can go through the numericals. I think we have solved around 15 to 20 numerical based on this atmosphere alone only, right? Now, another thing, even if you are good, if you have referred any particular book, for example, Anderson, right? So I have taken this diagram from Anderson only. So as you can see, in this region, so this is the mean sea level they are considering. So this temperature they are considering it's a 288.16 Kelvin at mean sea level, and it decreases at a rate of minus 6.5 into 10 to the power minus 3 Kelvin. So which is nothing but how much? Minus 0.0065 Kelvin per meter only, right? And in this region here, as you can see, it's almost straight line, right? This is what, as you can see, this is nothing what you can see. It's a straight line of this curve, something like this, right? So in this region, they are considering this A1 is equal to, just a minute. This A1 is equal to minus 6.5 into 10 raised power minus 3 Kelvin per meter. But here they haven't mentioned anything in this region, so you can write in this region A2 is equal to how much? Anyone? 0 only, right? Check. So this A2 is equal to dt by dh. So why this is 0? Because the temperature at 11 kilometer is how much? 216.5 Kelvin. Please check. And what is the temperature at 25 kilometer? It is nothing but you can say 216.5 Kelvin. So if you take the difference, like this dt upon dh is nothing but you can write A2 is equal to T25 minus T11 divided by H25 minus H11. So here, what is the T25 and T11? It is nothing but you can say 216.5 Kelvin only. So the numerator becomes 0. So your lapse rate is how much? Your lapse rate is equal to 0. But in from this 25 to 47 kilometer, your lapse rate is how much? A2 is equal to 3 into 10 to the power minus 3 Kelvin per meter. Or what you can write? How much you can write it? You can write it to 0.003 Kelvin per meter only. Then again, this layer is another isothermal region in atmosphere generally prevails at an altitude of 47 kilometer to 53 kilometer, right? And then again, as you can see, the temperature decreases. Then again, it remains constant, and again, it increases linearly. So what you can see in this region, your temperature, whether it's increasing or decreasing, either you can say it's constant, or you can say either, or you can say it is changing, but in linear manner only, right? Check. What do you mean by linear? Simply you can write it is following the rule, which one? Y is equal to mx, or you can say y is equal to mx plus c, right? Check please. Now, so if you want to answer this particular question, this one, which of the following statement is true as the altitude increases in stratosphere of international as standard atmosphere? First one, temperature increases. No. In this region, in isothermal region, what happens? Your temperature is constant. At what rate? You can say this temperature constant from 25. This temperature is constant from 25 kilometer to, sorry, from 11 kilometer to 25 kilometer, right? So it means that what? Your first option is wrong here. Second one, temperature remains constant. Yes, the temperature constant, but they are saying the pressure increases. No, the pressure will also decrease in this region. Density will also decrease, right? Check please. So option B is gone. Then temperature decreases and sound speed decreases. No, what is the sound speed? Am I audible? A is equal to root of gamma RT. So as you can see, this A11 is nothing but you can say root of gamma R T11, and the temperature, or you can say speed of sound up to 25 kilometer, or you can say at an altitude of 25 kilometer, is given by gamma R T25, right? So if we take the ratio, what you can write? A25 divided by A11 is nothing but gamma R and gamma R get cancelled. Ultimately, we'll get temperature at 25 kilometer divided by temperature at 11. So this temperature at 25 kilometer is nothing but you can say 216.5 Kelvin. At the same time, the temperature at 11 kilometers is how much? Yes? How much? 216.5 Kelvin only. It means that what? It leads to, you can say, this A25 divided by A11 is equal to root of 1, which is nothing but 1 only. So the temperature at 25 kilometers is nothing but, sorry, the speed of sound at 25 kilometers is nothing but you can say the speed of sound at 11 kilometers, right? So it means that what? Your speed of sound is constant. In which region? In the isothermal region of your stratosphere. Last option is temperature remains constant. Yes, and density decreases. So you can say option D is correct here. Now let's move to the next question. Here, generally, they are saying in a stratosphere, in which region? In the isothermal layer in the standard atmosphere, to be rho 1, V1, rho 1 and H1 respectively, the density variation with altitude in that layer is governed by. So which option is correct here? Just we have written this formula, right? So what is this? Rho 2 by rho 1 is equal to how much? E raised power minus G upon RTS in bracket H2 minus H1, right? Hello, am I audible or not? I'm taking this T suffix, capital T suffix S is nothing but you can say temperature at 11 kilometer, or you can say at propopause. Clear? Check please. So here option A is correct. It's a directly, you can say it's a derivation part. But in GATE 2008, they have asked another question, and it's nothing but you can say numerical. They are saying, assuming ISA standard sea level conditions, so the temperature is given 288.16 Kelvin, density is 1.225. Generally, we take it's a 1.2256 kg per meter cube, right? But here it is given 1.225, no issue at all. They are writing up to the 3 decimal points only. Then G is equal to 9.81, R is equal to 287 joule per kg Kelvin. The density in kg meter per cube of air at Leh, right? And they have given its a geometric altitude is 3,500 meter above the mean sea level. So how to solve this question? Write down solution. Let's see who can solve it first. Now, so the temperature at, let's say here, H is given 3,500 meter. Okay, that's the altitude of Leh. Right. Now, mean sea level conditions are given here. Temperature at sea level is given 288.16 Kelvin. Now, the density at sea level is given 1.225 kg per meter cube. Check please. Then G value is given 9.81. R value is given here 287 joule per kg Kelvin. Check. Am I audible to you?
Yes, sir.
Yes, sir.
Okay. Now they are asking, like, the density in kg per meter cube. They are asking at altitude of 3,500 meter. So how to calculate? Very easy. Add on. Temperature decreases linearly in the troposphere. Therefore, we can calculate the temperature at any altitude h by using the formula temperature in sea level plus lambda into h. Here, what is this TSL? This is nothing but it is a temperature at sea level conditions. Lambda is nothing but it is a lapse rate. Where? In troposphere region. Why we are considering this troposphere region? Because this 3,500 is nothing but you can say it's the altitude between mean sea level to the tropopause. What is a tropopause? Generally, you can say it is an interface between the two atmospheric layers, which is nothing but you can say the lowest layer is nothing but you can say the troposphere. Another one is nothing but you can say stratosphere here, right? Please verify.
Yes, sir.
Okay. So in this case, we can apply the relations which are useful in troposphere region. So we can calculate the temperature at H is nothing but you can say here H is nothing but you can say 3,500 meter only. To calculate what is the TSL here, it's a given 288.16 Kelvin. Please check. Plus how much? Lambda is, you know very well, in troposphere the lapse rate is given by minus 0.0065 Kelvin per meter, right? In troposphere. Now, so you can put lambda equal to minus 0.0065 here. Obviously, it is in Kelvin per meter. So please put H equal to 3,500. Please don't put here 3.5 kilometer. Okay, otherwise you will get the wrong value. Here it's a 3,500. Now please simplify it and let me know how much you're getting. What is this TH? How much you're getting?
265.41.
65.41.
How much? 265.41?
41.
Okay, 265.41 Kelvin. Please verify this value. Once you get the temperature at this altitude, of 3,500 meter, just apply the formula. Which one? Rho h upon rho SL is nothing but you can say TH upon TSL raised power how much? Minus of G upon lambda R plus 1. Check or not? Can you verify this one? Or directly you can write this value is nothing but you can say 4.2586 only, right? Check. So you can write here this rho h upon rho SL equal to TH is 265.41 divided by 288 raised power 4.6586, right? Sorry?
288.16.
Yeah, sorry. It's a 288.16. That's what we're given. Check. Just simplify it and let me know what is this ratio first. How much you're getting? Is rho h upon rho SL. How much you're getting?
0.7045.
7045.
7045.
7045. What Gadya? What is it? It's a unit less, it's a ratio, right? So you can calculate this rho h equal to 0.7045 into what is this rho SL? It is nothing but it given 1.225 or 2256. Please verify. Hello. How much it is given?
225 only, sir.
Okay. Just
225.
multiply and let me know what is the answer. What is the density at this 3,500 meter?
0.863.
0.863.
Sorry, come again.
0.863.
0.863. What is the unit? It's a kg per meter cube, right? Please take care of this one. That's your first answer, right? Let me check. So what is the range given here? It is given 0.85 to 0.88. So are we getting the value in between? Yeah, we are getting 0.863, right? Hello, am I audible?
Yes.
Here the range is given 0.85 to 0.88, right? It means that your calculation is absolutely correct. In GATE exams, you know what is the most important thing? That's accuracy. So please take care of your calculation. Don't be hurried. Now, let's move to another question. In 2022, they have asked another question, which is nothing but for international standard atmosphere up to 11 kilometer, which of the following statement is or are true here? First of all, they are saying the hydrostatic, or sometimes we call it the aerostatic question is used. Yes, we generally use this one. Okay. Then the temperature lapse rate is taken as 10 raised to power minus 2 Kelvin per meter. No, not at all. What is the lapse rate in troposphere? It's a minus 0.0065 Kelvin per meter. And if you want to write like this one, then how much you can write? What you can write? Lambda equal to, yes, how much?
Minus 6.5 Kelvin per kilometer.
How much? Minus 6.5
minus
into 10
6.5
power?
Kelvin per kilometer.
into 10 to power minus 3 Kelvin per meter.
Yeah, you can write it's a Kelvin per kilometer, or you can write it's a 10 raised power minus 3 Kelvin per meter also, right? So please take care of this one. You can write it's a minus 6.5 Kelvin per kilometer, right? Or what you can write? You can write lambda equal to minus 6.5 into 10 raised power minus 3 Kelvin per meter also. So please take care. Now, what do we say hydrostatic equation? Even if you ask this question from, you can say the second year student, those who are, you can say in their third semester, right? And those who have gone through this introduction to aeronautics, or you can say aerospace course, generally it start with the atmosphere only. So generally we use the formula P equal to rho GH, or you can say dP equal to minus rho. What is the
TP is equal to minus rho GDH.
Generally we write it's a P equal to rho GH, right? So
yes,
the change in pressure dP is nothing but it is minus rho G into dH. Why we are taking this minus sign here? Anyone? Because the pressure is decreasing as the altitude is increases. That's the basic definition of your international standard atmosphere, right? Check. Are you getting this one? So generally
Yes,
we
sir.
use hydrostatic law. So the first option is correct. The temperature lapse rate is taken as no, not at all. It should be minus 6.5 into 10 to the power minus 3 Kelvin per meter or Kelvin per kilometer. Then the sea level conditions taken as pressure is equal to this much. Yeah, pressure is correct. Temperature, they have taken temperature here 300 Kelvin, that's wrong. And the density they have taken 1.225 kg per meter cube. So here the temperature value is only wrong. Generally we take it's a 288 or you can say 288.16 Kelvin only. So you can say out of these values means pressure, temperature and density, here the temperature is wrong. So it means that what? Your option C is also incorrect. Your option B is already means get eliminated. Now D here. Air is treated as perfect gas. Yes, very true. Why? Because we are using the equation of state, right? Hello, am I audible or not? We are using the equation
Yes, sir.
of state here. You can write P is equal to rho RT. We have taken this assumption in the calculation of troposphere as well as you can say in the stratosphere, right? During the derivation part. It means that your option D is also correct. Now let's move to another question. They have asked in GATE 2023 for 2 marks. So this is the last question, I think, from this ISA. Consider the international standard atmosphere ISA with H being the geopotential altitude in kilometer and dt upon dH being the temperature gradient. So this temperature gradient is nothing but what? What is this temperature gradient? Lambda is equal to
Lambda.
dt upon
dt by
dH,
dH.
right? So what is the difference between the gradient and rate? Generally in engineering, you can see these two things are very common, right? Pressure gradient, temperature gradient, density gradient, velocity gradient is also there, right? Check. So whenever
Yes, sir.
you are talking about the gradient, it is related with the displacement, or you can say change along the length, width, or you can say dt upon dH, or you can say, for example, if you are writing dp upon dx. So what is this? It's a pressure gradient in x direction. It may be, you can say dp upon dy. It may be, you can say dp upon dz. But what is the rate? Anyone? What is the rate?
Related with time.
Very good.
dp by
You can
dt.
say dx upon dt, right? dy upon dt. So this is nothing what you can say. Rate of change of displacement is what? That's a velocity only, right? Check please. It's a 6th class mathematics only. So in this case, look, again, it's a direct question from, you can say the ISA. They are saying option A is given here, like here it is given kilometers, right? It is the altitude h comma dt upon dh. So you can write h comma lambda. Means here this is the altitude, right? Altitude, and here lambda is nothing but you can say it's a lapse rate. Clear?
सर वो उसका फॉन्ट ब्राइटनेस बढ़ा सकते हो क्या क्वेश्चन का? वो दिख रहा नहीं एक्चुअली क्वेश्चन.
ये
नहीं सर, वो कंसिडर वो ब्राइटनेस उसका बढ़ा सकते हो?
The question
okay,
one.
okay, just wait. Now visible?
Okay sir.
Yes, sir.
Now check. Is it visible to you or not?
Yes, sir.
Yes sir, visible.
Okay. Now consider the international standard atmosphere ISA with h being the geopotential altitude. So here what is given? H comma dt by dh. So what is this h here? That's altitude. And what is this dt upon dh? You can say it's a temperature gradient, or simply you can write it's a lapse rate. As an aeronautical engineer or aerospace engineer, we are very familiar with this dt upon dh value, right? Check. Now, so in troposphere, again, let me tell you, in troposphere region, from mean sea level to 11 kilometer means up to the tropopause. What is the lapse rate? You can write lambda is equal to minus 6.5 into 10 to the power minus 3 Kelvin per meter. Agree? Now, from 11 kilometer to 25 kilometer. That's a isothermal region, or you can say that's a isothermal region in the stratosphere region, right? Here, what is the lapse rate? Lapse rate is 0. In this region, from 25 to 47 kilometer, this lapse rate here A is positive, means your temperature is increasing, right? So it is given 3 into 10 to the power minus 3 Kelvin per meter, right? Then again, from this 47 to 53 kilometer, this lambda value is 0. And in this region, again, you can write this lambda is nothing but you can say minus 44.5 into 10 to the power minus 3 Kelvin per meter. Please take care of these values, okay? Again, from 79 kilometer to 90 kilometer, your lambda value becomes 0. Are you agree or not? Then again, from 90 to 105, they are considering this lapse rate is nothing but you can say lambda is equal to 4 into 10 to the power minus 3 Kelvin per meter. In books, it is written A, but I'm taking here, you can say lambda, because sometimes students get confused between speed of sound as well as in the lapse rate. Okay, so better take lambda value. Or if you study any standard book, except this Anderson, you will get the notation very famous. You will get these notations like lambda only. Okay. Now, so in this region, what is your option A? When the altitude at an altitude of 7 kilometer, your lapse rate is given how much? It is given minus 6.5 into 10 to the power minus 3. Meaning what? Check. Is it correct or not? And it is given in Kelvin per meter. So it means that this option A is correct here. Second one, at 9 kilometer, you can say it is given 4 into 10 to the power minus 3. No, this is wrong. Why? Because from mean sea level, means from H equal to 0 to H equal to 11 kilometer, your lapse rate is given minus 6.5 into 10 to the power minus 3 Kelvin per meter. Are you agree? It means that what? At 9 kilometer also means it should be minus 6.5 into 10 to the power minus 3 Kelvin per meter only. Are you agree? So it means that what? Your option B is also gone from here, right? Now look at option C. They are saying at an altitude of 15 kilometer, your lapse rate is 0. So you know very well in the isothermal region, what happens? The temperature remains constant from 11 kilometer to 25 kilometer, right? Say yes or no?
Yes, sir.
So if the temperature is constant, it means that what? Your lapse rate, which is nothing but the temperature gradient, dt upon dh becomes 0. So your numerator becomes 0, means the change in temperature is 0 from 11 kilometer to 25 kilometer. So they are saying at 15 kilometer, obviously this lambda is equal to 0. It means what? Your option C is also correct. Now look at option D. They are saying at an altitude of 35 kilometer, the lapse rate is here 3 into 10 to the power minus 3. You know very well, after 25 kilometer, your temperature increases. It means that what? It means that your lapse rate increases. Agree or disagree? If the temperature increases, it means that what? Your lapse rate is positive. And at what rate? This dt upon dh, or you can say the temperature gradient varies at the rate of 3 into 10 to the power minus 3 Kelvin per meter. It means that what? Your option D is also correct. Agree, Maharaj ji? Prabhu, are you there? Devi?
Yes.
Okay, very good. Now, it means that what? Your option A, option C, and option D is correct here. They have asked, I think, for 2 marks. It's the question number 45 in GATE 2023. Now, from here we are starting. You can see the instrument. They are saying a conventional altimeter is a pressure transducer, temperature transducer, density transducer, or velocity transducer. Obviously, what is the use of the altimeter? Look, have you visited anytime the instrument lab in your college or university? Even have you seen the cockpit? Have you seen any model or not? First, let me, or are you just only
No, sir.
इंस्ट्रूमेंट नहीं है कॉलेज में? हाँ,
No, sir.
आना मेरी यूनिवर्सिटी, दिखाता हूँ तेरे को. So you can write option A is correct here, right? Now, which one of the following fact instrument is used on an aircraft to determine its altitude in flight. So to determine the altitude, generally we use the altimeter, right? Check please. What we use? We use the altimeter. Is that clear?
Yes, sir.
So here again, option B is correct. It's a straightforward question. During an aircraft cruising flight, the altitude above the ground is usually measured using dynamic pressure, static pressure, radar, or you can say laser range finder. Obviously, if you know the static pressure, you can use, you can say the pressure altitude, or simply if you know the static pressure, we can calculate like what is the altitude of the aircraft, right? Now again, indicated airspeed is used by a pilot during takeoff, navigation, setting the engine RPM, setting the elevator angle. Obviously, option A during the takeoff only. Jens, shall I have butter, please? Now, so shall we start with the main portion of your aircraft performance? That's a performance in cruise flight. So look here, yeah. So generally we have means segregated these questions based on the topic like study level flight, then how to calculate the minimum speed, maximum speed, and stalling speed, right? Then we are having, you can say, range and endurance questions in study level flight, or you can say during the cruise. Again, we can classify based on whether it's a piston engine aircraft, or you can say it's a propeller based aircraft, or you can say whether it's a jet engine aircraft, right? Say yes or no? Then we are
Yes,
having
sir.
gliding, we are having, you can say, the climbing also. So shall we start with this question?
Yes, sir.
Simran, are you there?
Yes, sir.
क्या हुआ? साइलेंट क्यों इतना? डर लग रहा है क्या एग्जाम का? हाँ,
थोड़ा सा सर.
पढ़ाई करो पढ़ाई. Now, an aircraft has zero lift coefficient, zero lift drag coefficient. So here, this is given CD naught is equal to 0.0223. Second one, aspect ratio of the wing is given 10. Oswald efficiency factor, or you can say the span efficiency factor here is 0.7. Then what is given? Nothing is given, right? Now what we are asking, thrust required for a steady level flight will be minimum when the aircraft operates at a lift coefficient of. So please remember, we are having just only three conditions, right? In aircraft performance, which is nothing but you can say minimum drag condition, or you can say minimum thrust required condition. Then we are having minimum power condition, and then we are having minimum D by V ratio condition, right? Say yes or no? Check, am I audible or not?
Yes, sir.
Okay, so what is the minimum drag condition? What is the minimum drag condition? Yes, please. What is the minimum drag condition? Anyone?
Sir, condition at which induced drag equal to parasite drag.
You can say minimum drag condition or minimum thrust required condition is nothing but you can write CD naught is equal to CTI. Means your parasite drag coefficient, or you can say the zero lift drag coefficient is exactly equal to what? You can say the induced drag coefficient CTI. Now again, what is the CDI? The CDI is nothing but you can say CL square upon pi ER only, right? Check. Hello? Am I audible?
Yes.
Now, so just find out. So you can write the CD naught is equal to how much? CDI. What is the CDI? The CDI is nothing but you can say KCL square, right?
Yes,
What is
sir.
this K?
Yes.
K is equal to 1 upon pi EAR, right? Check please. So each and everything is given in this question. Aspect ratio is given, Oswald efficiency factor is given, CD naught is given, right? Just calculate what is the value of K. K is nothing but 1 upon pi. E is given here 0.7 into aspect ratio is 10. Please calculate and let me know how much you're getting. It's a pi into 0.7 into 10. How much you're getting? Anyone? What is the value of K?
0.0454.
I'm getting 0.0
4,
284, right? Check. Are you getting this value?
Yes,
Yes,
sir.
sir.
So you can write up to the, you can say the 5 decimal points. You can write here this CDI, sorry, this K equal to, just wait. You can write the K equal to how much? It's a 0.04547, right? Check. Now apply the condition. CD naught equal to CDI. What is the value of CDI from here? Or simply you can write CDI equal to CD naught, right? What is the CDI? The CL square upon, or you can write KCL square equal to CD naught. From here you can write the CL square equal to CD naught upon K. If we simplify it further, you can write the CL equal to root of CD naught upon K. Check please. So what is the lift coefficient? What is the value of CD naught in this question? It's a CD naught is given how much? 0.0223, right? 0.0223 divided by K, we have calculated 0.04547, right? Check please. Now let me know what is this value. 0.0223 divided by 0.04547 root of answer. How much you are getting? Are you getting
0.7.
0.700.
I'm getting 0.70030309397. Are you getting this value?
Yes, sir.
Yes, sir.
So here, if suppose, so in this question, or you can say the given options are what? You can say up to the 2 decimal places only, right? So just remove this one. So you can write CL equal to 0.70. So which option is correct here? You can say here option B is the right option, right? Check please. Are you getting? Now, the second part of this question is given like what? We are saying the glide angle that results in maximum range in a power of glide. Yes, what do you mean by power of glide? Anyone? Yes, please.
So unaccelerated gliding.
Huh?
Unpowered gliding, sir.
What is the meaning of that? So which component is zero? If you are saying it's a power of
Thrust.
glide, means what? You can say the thrust is zero, right? So just if I draw here the diagram, then you may consider, let's say this is the, okay, just wait, okay, just wait. Let me draw here right path. Let's see. We are having one glider. We may throw here something like this. Okay. Please draw this diagram. Let's consider this is nothing what you can say the CG. Okay. Now let's draw here one local horizon, something like this. Please check. Look, is it straight or not? Almost straight, right? Check. Let's consider This angle is nothing but you can say flight path angle, or you can say it's a glide angle. Okay, please take care of this one. So generally we define this by gamma, right? Now here we are having another angle. If I draw a line through this CG only, through this CG, but from where? From the chord line of this, something like this. Okay. Now, just wait. Yeah, this one. This angle. Okay. So this is nothing but simply you can see it's a chord line. Just wait. So this angle is nothing but you can say angle of attack alpha. Okay. But what is this angle? Can you tell me? Sorry, just a minute. What is this angle? What is this angle here? What is the angle of attack? The angle between the free stream velocity, or you can say relative wind, and the chord line of the wing, or you can say aerofoil, is nothing but you can say the angle of attack, right? Alpha. Am I audible or not? If suppose this is our aerofoil, let's draw here. This is the chord line. Let's say this is the direction of free stream velocity. Then the angle between the chord line and the free stream velocity vector, or you can say relative wind, is nothing but an angle of attack. So can you relate here? I'm considering, let's say it is moving along this particular path with some velocity b infinity, right? So the angle between the b infinity and this one is nothing but you can say angle of attack alpha, right? And this is what? This is nothing but you can say gamma. Now can you tell me what is this total angle? What is this total angle? This angle, or you may write, this is nothing but you can say simply it's a FRL, fuselage reference line. Am I audible? Here this FRL and the chord line of your aerofoil, or you can say wing, are coinciding. So you know very well the angle between the local horizon and your FRL, or you can say this body axis, is nothing but we call theta. What is theta? Anyone? What is theta? We call it a pitch angle. So what is the pitch angle? Theta is equal to gamma plus alpha. Check please. Are you agree?
Yes, sir.
Right? Check. So this is nothing but you can say simply, you can say it's a theta. Calculate. Now, what I want to convey in this case, just a minute. Okay. So in case of gliding, okay, let me draw here another diagram, something like this. Let's see. This is the aircraft, and this is nothing but you can say glide angle gamma here I'm considering. Okay. In this case, your thrust is equal to 0. Right? Let's say it is free stream velocity vector b infinity. Now, this is nothing but the center of gravity of this particular body. You can throw here. The weight is always x vertically downward. Are you agree? Simran, are you there?
Yes, sir.
So that's nothing but you can say weight W. Now, what is a lift here? Lift is always normal to or perpendicular to what? Perpendicular to this free stream velocity vector, right? So lift is here. Let's say that's a lift. And then we are having drag also. So where is the drag? Drag is something like this only. That's a. You can resolve it. But if you extend this line further, what is this angle? This angle is nothing but you can say gamma once again. Right? Check please. So we can resolve these forces along the flight path, or you can say along this straight line. So what you can write here? L is equal to W cos gamma, check, and L is equal to, if you take the component of this one, then this angle is gamma. So L is equal to W cos gamma. Another one is what? D is equal to W sine gamma. Check please. So here you can write D is equal to W sine gamma. Right? Now, if we divide, let's say this is nothing equation 1 and this is nothing but equation number 2. So if we divide equation 2 by 1, what we can write? Sine gamma divided by W cos gamma is equal to how much? How much you're getting? L by D or D by L?
D by L.
D by L. So
D by
this
L.
W and W get cancelled, right? If you simplify it further, what you can write? This tan gamma is equal to D by L. You know very well. This D by L can also be written as CD by CL, right? Check please. Clear? Hello, am I audible or not? Or what
Yes,
I can write, if I want to write, if we further simplify it, what we can write? It's nothing but 1 upon L by D or 1 upon CL upon CD. Now, what is the CL upon CD or L by D? You can say this is nothing but the aerodynamic efficiency, right? Check please. What can we call? We call it's a CL by CD ratio, L by D ratio, or we call what? It is the aerodynamic efficiency of the whole aircraft. Clear those? Now,
Yes, sir.
what is the condition for maximum L by D condition, or you can say maximum aerodynamic efficiency? Means under what condition maximum L by D condition can be achieved? Anyone? Under minimum drag condition, minimum power, or minimum DYV condition? Yes.
Minimum drag.
Minimum drag condition. Very good. Right? Now, so what I want to convey here, this tan gamma is nothing but, you can write gamma is equal to tan inverse of how much? 1 upon CL upon CD, right? So this gamma tends to gamma minimum when the CL upon CD ratio or L by D ratio tends to what? You can say CL upon CD max, right? Agree? So what you can write? You can write gamma minimum, or you can say tan gamma minimum. It's up to you. If you want to write, you can, no issue at all. It's 1 upon L by D max is equal to 1 upon CL upon CD max, right? Check please. Hello? Now, let's say the aircraft is gliding from a certain altitude. Let's say this altitude is nothing but you can say H, and this is nothing but you can say flight path. This angle is nothing but gliding angle, gamma, or flight path angle. And this is nothing but you can say, what is the horizontal distance covered during? The horizontal distance covered by the glider during the glide is generally known as what? It's known as the range in the glide, or you can say simply, it's a range of a glider. Agree or not?
Yes,
Hello?
sir.
Now, what we are asking? We are saying the glide angle that result in maximum range in power of glide. Hello? What they are asking? They are asking like the angle of the glide angle they are asking that result in maximum range in power of glide. Now, look here carefully. So if suppose, if you are writing, this is the altitude H from where, let's say, it start descending, okay? And this is nothing but you can say R, then what you can write? If you want to write the relation between H, R, and gamma, definitely you can write tan gamma is equal to how much? Anyone? If this angle is theta, or you can say gamma, then this is nothing but a perpendicular, right? And this is nothing but you can say base. So what is tan gamma here? Tan gamma is nothing but perpendicular, right? So what is the perpendicular here? H divided by base. So what is the base here? R. So from here, what you can write? What you can write here? R is equal to H upon tan gamma. Check please. Hello?
Yes, sir.
Are you agree or not? So meaning what? Either you can write it directly, right? When this tan gamma is minimum, right? This tan gamma is minimum, then you can say R tends to what? R max. Why? Because if this denominator value decreases, then this overall value increases. Or if you are not means compatible, then you can write one more step here. like h divided by, what is the value of this tan gamma here? We have already written this tan gamma is nothing but you can write it's a 1 upon L by D, or you can say 1 upon CL by CD ratio, right? So put here this tan gamma is nothing but you can say L by D, sorry, D by L, right? Sorry, 1 upon L by D, right? Check. Are you agree? Because tan gamma is given by 1 upon L by D, or you can say CL by CD ratio. So you can write here H into L by D, or simply you can write R is equal to H times of CL upon CD ratio. So what you can conclude from here? Again, you can write, since you know this altitude is not going to change, it is well defined. Whether this start descending or gliding from 1000 meter, 500 meter, like that only. So H is not going to change. But as you can see, H is constant. So R is directly proportional to what? The CL upon CD. So if the CL upon CD is increases, then the value of capital R is also increases. But the CL upon CD is also having the limitations, right? Check. So you can write this R max corresponds to what? Corresponds to L by D tends to L by D max, or what? The CL upon CD ratio tends to CL upon CD max. Are you agree or not? Please verify this value. Okay. So from here, what you can write, Prabhuji? R is equal to H into L by D max. R max is equal to, or H into CL upon CD max. Check. Right? So calculate what is this R max? No, what they are asking, R max is equal to just wait H into L by D max. So they are asking what is the angle of glide, right? Hello, what is the corresponding angle of glide? Corresponds to what? Corresponds to maximum, the glide angle that result in maximum range in the power of glide. So meaning what? Tan gamma is equal to 1 upon L by D max, right? Leads to what? Gamma minimum here leads to tan gamma minimum. Therefore, what you can write? Gamma minimum is equal to tan inverse of how much? 1 upon L by D max, right? Check please. Now just find out. Now from this data, we have already calculated like what? The value of CL is how much? How much you are getting? This value of CL is 0.70, right? Hello, what is the value of CL? So 0.70. Now what is the drag polar of this aircraft? You can write CD equal to CD naught plus KCL square. Check. So what is the value of K here? We have calculated CD naught is nothing but how much it is given? CD naught is given 0.0223, right? 0.0223 plus K value is how much? Can you tell me? Hello? Already we have calculated it's a 0.04547, right? Plus 0.04547 CL square, right? Check. It's a very easy question. Now, you know very well. What do you know? Simply, you can write for minimum drag condition or maximum L by D or maximum CL upon CD, aircraft has to fly under the minimum drag condition. And what is that condition? The CD naught is equal to CDI, right? So what is the value of CDI in this case? CD naught value is nothing but you can say 0.0223. So can you tell me what is the value of CD? If you put CD naught, CDI is equal to CD naught in your drag polar equation, if you put here the CDI is equal to CD naught, this particular value, how much will get? CD naught plus CD naught, right? So what you can write? This CD is nothing but you can say twice of CD naught. Please don't skip any step. So simply you can write CD is equal to how much? it's a 0.0223. So just twice of this value, right? Right? So 0.0446. Are you getting this one?
Yes, sir.
0.0446, right? Simply 3 to the 6, 2 to the 4, 2 to the 4, 0. So that's nothing but you can say that's a value of CD under minimum drag condition. And obviously the value of CL under minimum drag condition you have calculated the 0.7, right? Now this LYD max is corresponds to what? Or CL upon CD max is corresponds to, yes, corresponds to what? Anyone? It's a CL and D divided by CD and D. That's it. Minimum drag condition. So CL is how much? 0.70. What's the CD and D? You're getting 0.70 divided by 0.0. How much? 446?
446.
446.
446. Right? Simplify this one. Where is the calculator? 0.70 divided by 0. How much you're getting?
15.69506.
15 point.
69506.726.
I'm getting 15.69506.726, right? So you can write up to the 3 decimal point or 4 decimal points. You can write it's a 15.6951. Okay, that's your LYD max, or you can say CLY CD max, right? Check please. Just put here what is this gamma minimum value. You can write this gamma minimum is nothing but how much? 10 inverse of how much? 1 upon, tell me. Yes, LYD max we have calculated now. Check. It's a 15.6951, right? 15.6951. Can you tell me this value, please? Can you tell me?
3.6456.
Gamma minimum is equal to how much?
3.6456.
56.
Yes, sir.
56. What? Gadia Gode. What is this? Radians or degrees? Yes, please.
Degrees.
Hello?
Sir,
In
degrees.
Okay, please take care. Units also. So we are asking up to the 2 decimal points here, right? So we can write here it's a 3.65 degree. That's what we are getting. Okay. So what is the nearest answer here? We can write option C. Clear those? Check please.
Yes, sir.
Okay. Now next one. Next question is an aircraft in level and unaccelerated flight with a velocity of 300 meters per second requires a power of 9 into 10 to the power 6 watt. Okay. If the aircraft weight is 1.5 into 10 to the 5 Newton, the lift to drag ratio, that is L/D ratio, is, it's very easy, right? So what we are saying in level and unaccelerated flight means what? This aircraft is cruising something like this, right? Hello. So during the cruising, just draw this diagram. Let's say this is nothing but you can say aircraft. It is flying at certain altitude, right? It is flying at certain altitude from the mean sea level, something like this. Let's say this is H, which is unknown. Now you're saying it's a forward speed. This B infinity is nothing but you can say 300 meter per second. Okay. They are saying it requires the power. So what is the power required here to fly this aircraft? PR equal to
TR into V infinity.
it's a 9 into 10 raised power 6 watt.
Yes.
Okay. Now, if the aircraft weighs 1.5 into 10 to the power 5 Newton. So first of all, in steady state and level flight, you know very well what is the equation of motions here, or simply what about under what condition this aircraft can fly? You can see the weight always acts in vertically downward position. So that's W. Lift will be somewhere like this, right? And here, obviously, this is nothing but you can see a thrust required. and this is nothing what you can say your drag. So in this case, what happens? Your thrust required is equal to drag and lift is equal to weight. Agree or not?
Yes, sir.
If you take the equilibrium here, like summation of the forces, let's consider this is nothing like an x direction and this is nothing but z direction. So you can write summation of forces in x direction is equal to 0, summation of the forces in y direction is equal to 0, summation of the forces in z direction is equal to 0. So very easy. Summation of movement about any particular point. So we can replace this whole aircraft by a point mass system, right? Hello, Maharaj, are you there? So you can write usual summation of the moments about the center of gravity generally we take, right? Then only we can say this aircraft in the stable condition, right? Check please.
Yes, sir.
Now, so we are getting this relation with the help of this one only, this one by this only, right? What do you know? The power required is nothing what you can say drag into the forward speed of the aircraft, right? But in steady state and level flight, what is this thrust required? This thrust required is nothing what you can say the drag of this aircraft. So sometimes you can also write the power required is nothing what you can say thrust required into the forward speed of the aircraft. Okay, very good. So what is given in this question? Yes, what is given? You can see the power required is given how much? 9 into 10 raised
10 to power
power 6 watt is equal to thrust required into what is the forward speed of the aircraft? It is 300
300.
meter per second. So from here, can you calculate what is the TR? TR is nothing what you can say 9. 10 power 6 what I can write? It's 1,000, right? Into 1,000 divided by how much? 300, right? Check. Shall I write here? Hello,
Yes,
Prabhuji? So this 0 and this 0 gone, right? 3 3s are 9. So how much we will get?
30,000.
Thrust required is equal to, you will get around 3,000 into 10. So that's nothing but you can say 30,000 what? Newton, right? Or you can write it's a 30 kilonewton. Now what they are asking here, they are asking the lift to drag ratio is. So the weight is given or not? Yeah, weight is also given, right? So weight is given how much? 1.5 into 10 raised to power 5 Newton, right? Now, with the help of these two equations, which one? Thrust required is equal to drag and L is equal to W. What we can write? We can rearrange these equations like thrust required during cruise flight, or you can say during steady state and level flight, which equal to how much? W divided by L by D or CL by CD ratio. Say yes or no, first of all.
Yes, sir.
Are you agree? If you simplify it further, what you can write? TR is equal to W divided by L by D, or simply you can write thrust required is equal to W divided by CL upon CD. So what is known to us now? The weight of the aircraft is already given, right? It is flying in steady state and level flight, then only we can apply this one. Now, second thing, we have calculated the thrust required value, right? With the help of the formula, power required is equal to, you can say drag into the forward speed. Now this drag is exactly equal to what? You can see the thrust required in a steady state and level flight. Say yes or no first.
Yes, sir.
Can you write thrust required is equal to D in case of, you can see the climbing flight, or T is equal to D in case of climbing flight? Just connect. We cannot, right? Hello. Am I audible or not? In case of climbing
Yes, sir.
flight, what happens? Your thrust is equal to D plus, you can say one of the component of the weight of the aircraft. Why? Because the lift during the climbing flight is lower than the weight of the aircraft. So that's why you will get one relation from there, L is equal to W cos theta, or you can say W cos gamma, based upon what you are taking this climbing angle, whether you are taking gamma or whether you are taking the theta. So what I have taken during the classroom, theta or gamma?
Sir,
Please
gamma.
let me know.
Gamma,
Okay,
sir.
if I have taken the gamma, please take care of gamma only, right? So even if we talk about the load factor during the climbing flight, it is what? It is positive, but lower than what? Lower than 1. Say yes or no?
Yes, sir.
What is the load factor? N is equal to L by W only, right? Say yes or no first.
Yes, sir.
So you are getting L equal to W cos gamma. So cos gamma is equal to what? L by W. So what is this L by W? This L by W is nothing but it is a load factor. So you can write N is equal to cos gamma, right? So if suppose if this gamma is equal to 0, so under what conditions this gamma is equal to 0? During the cruise flight, you can say the climbing angle is 0, gliding angle is 0. At the same time, what? At the same time, you can say, what is this angle? Look, yes, you can say your bank angle is also equal to 0. Say yes or no first. During the cruise flight, or you can say during steady state and level flight, you can say, you can write somewhere, you can see your climbing angle is 0, right? Your gliding angle is also 0. Then another, you can say the wings are level, right? It means that what? It means that your banking angle, or you can say bank angle phi, is also equal to 0. Now, but in case of this, if you redraw which diagram, that theta, gamma, and what, and alpha diagram, then you can relate like what? This theta is equal to alpha during the cruise flight. Am I audible or not? Means your angle of attack is exactly equal to what? Angle of attack is exactly equal to what? You can say your pitch angle theta, right? Hello, we will discuss, don't worry. So just put here, what is the value of W? W is nothing but you can say 1.5 into 10 to the power 5 divided by how much? CL upon CD. Is it given in this question? No,
Sir, we
they are
have to
asking.
find out.
Okay,
From the
we have
previous
to
question.
calculate like what is this L by D or CL by CD, right? So from here, what I can write? L by D is equal to how much, Prabhuji? Devi, are you there? So here you can write it's a 1.5 into 10 to the power 5 divided by L by D is, sorry, thrust required is how much?
30,000.
We have calculated 30,000, right? So just put here. Akash Prabhu, are you there?
Yes, sir.
Ram, are you there?
Yes, sir.
पवन, are you there? तो क्या मतलब क्या चल रहा है उधर बैठ के? हाँ?
Yes, sir.
Then why you are not answering in the class? फालतू में. Now from here you can write L by D is equal to how much? Just simplify it. What
So
you can
5
write?
is
You can write 1 5, right? 0 0 0 0. Is it correct?
yes, sir.
Shall we write or not? So 0 0 0 0 0 0 0 0 gone. How much you are getting?
So
L by D
5.
is equal to 3 का पारा आता है, you know the table. You can write 3 5s are 15. So L by D is equal to 5 only. That's the answer. Okay, right? So even the range is given here from 5 to 5. It means that your answer is correct. Yeah, the pitch angle and the angle of attack for a fixed wing aircraft are equal during wings level, constant altitude flight, unaccelerated climb, unaccelerated descent, landing, and which option is correct here? Option A. How? Let me draw this diagram. Hello, am I audible to you or not? First, let me know.
Yes, sir.
Can you draw these diagrams? Let's consider. Let's say one aircraft is in plan something like this. Okay, let's consider. Just give me that. Let me draw one second. Let's see if this is the aircraft. Something like this. Okay. Now let me draw here. It's a fuselage reference line, FRL. That's nothing but you can see your FRL. Let's see, this is the wing. Something like this. Okay. You can write it's a FRL, or you can say it's a body axis. Actually, right? Now, very simple tail. Draw one line. through its CG, something like this. Just a minute. Okay, let's consider this is a CG of this aircraft. Clear? Am I audible or not?
Yes, sir.
Now, let's consider this aircraft is moving. Just a minute. Let me throw another line here. Let's say this airplane is moving along this particular line. Something like this. Okay. Here, this red line is nothing what you can say. It's a local horizon, right? What do you mean by local horizon? Anyone? Or local horizon is nothing but simply if you are taking any reference, something like this. Let's say. Okay. So what is this angle? This angle. Here, I'm considering this aircraft is moving along this flight path. So the angle between the local horizon and the flight path is nothing but you can say the angle of climb, that's a gamma, or you can say simply you can write that's nothing but what? Anyone? That's nothing but what? That's a flight path angle, or you can say angle of climb. Then what is the angle of attack? The angle of attack is nothing but you can see the angle between the free stream velocities. So let's consider the wind is coming from this direction, or you can say, let's say the aircraft is moving along this direction, something like this. So let's consider it's a V infinity. So you know very well the angle between the relative wind, or you can say free stream velocity vector and chord line is nothing but you can say angle of attack. So this angle is how much? This angle is alpha. Say yes or no first of all, Prabhuji.
Yes, sir.
Clear? Now, what is a pitch angle? This pitch angle is nothing but you can say. This angle is the pitch angle. Which one? This one.
The angle of attack plus climb.
Sorry, come again.
The angle of attack plus climb angles.
Yeah. So what if you want to represent it graphically, then you should have to understand. Like you know very well theta is equal to gamma plus alpha only. But how to draw this one? Clear? Regarding this one, no? Means your aircraft is moving something like this. Look, it is moving along, you can see this black line, or you can say black path, something like this. Okay, but it's a reference line, or you can say the fuselage reference line, or you can say XV axis, or you can say the chord line. They are constant with each other, and this is the angle of attack. So what is the angle of attack? The angle between the chord line and the free stream velocity vector, or you can say relative velocity, the relative speed. So from here we can write this is the theta. What is this theta here, Prabhuji? Hello, what is this theta? Theta is generally known as what? Yes, that's a pitch angle. So from here, what you can write? The pitch angle is equal to, you can write angle of attack plus what we have called this angle?
Climb angle.
What we have called this angle? Flight path angle, or see what means by flight path? See, if suppose this aircraft is in climb, right? Then the angle between the free stream velocity vector and local horizon. Okay, let me write here. Let's say this is nothing but you can say local horizon. The angle between the local horizon and the velocity vector, or you can say free stream velocity vector, is nothing but we call what? We can say the flight path angle. So during the means climbing, when the aircraft is gaining the altitude, generally we call it as a climb angle, or you can say angle of climb. Okay, and same angle during the descent, or you can say during the gliding, generally we call angle of glide. Is that clear? Hello?
Yes, sir.
Yes, sir.
That's it. Now, so angle of attack plus you can write here gamma I'm taking. So you can write theta is equal to alpha plus gamma. Now look carefully. If suppose if we talk about, you can see the steady state and level flight. Which flight? Steady state and level flight, or you can see the cruise flight. Then what happens? The aircraft is moving, let's say okay, let's say this is nothing but you can say FRL. Let's say this wind is just a minute, just a minute. Is it visible to you or not? Check, is it visible?
Yes, sir.
FRL as well as you can see it's a quad line. Just wait, let me change the color. Something like this. Okay. Now let's see, this is the local horizon, right? And this is nothing but you can say V infinity. So during the cruise flight, you can write your theta is equal to alpha. Check please. Hello, am I audible or not? Because
Yes.
your local horizon, this angle, this gamma becomes 0 during the cruise flight. What is gamma here? Gamma is nothing but you can see if suppose it's if the aircraft is climbing, right? And after some time when it gets, you can see its wings are level, something like this, and it is moving with, you can see the constant speed. So in steady state and level flight, what happens? Steady means what? You can say it is moving with the constant balance speed, right? Or you can say dv upon dt is equal to 0 means acceleration is equal to 0. Is that clear or not? Say yes or no first.
Yes,
If
sir.
v is equal to constant, then what is the acceleration of the flight? Acceleration is equal to 0. And you know very well, during the cruise flight, your gamma is equal to 0. Whether you are taking gamma as the climbing angle or you can say gliding angle, right? So that's equal to 0, right? Say yes or no first of all.
Yes, sir.
As
Yes,
well
sir.
as you can see the wings are level, something like this. Wings are level, something like this, right? Means what? You can say this phi is also equal to 0. During the turning, generally, we have to take the, or during the turning, you can say the phi exists, or you can say phi comes into the picture. So please write somewhere phi equal to 0, gamma equal to 0. So I'm writing a flat path angle equal to 0, or you can write angle of climb, or another you can write it's a angle of glide, or simply you can write climbing angle, and gliding angle equal to 0, right? Check. So which one is the correct option here? Wings level constant altitude flight means that's nothing but you can say your cruise flight during steady state. What do you mean say low? Hello, do you understand altitude? Constant altitude flight means what? During the cruise condition, you can see the altitude is what? Altitude is constant, it's not going to change. Now, next one. Yes, please.
सर वो ही प्रीवियस डायग्राम एक बार अनएक्सेलरेटेड डिसेंट के लिए बनाना, मतलब पिच एंगल और फ्लाइट पैथ एंगल को शो करके.
ठीक है. During the glide, right? Hello? During gliding?
नहीं सर, अनएक्सेलेरेटेड डिसेंट.
Descent means what? Gliding only, na? Descending. Hello?
Yes sir.
Descent means what? Means the aircraft is gliding. What do you mean by descent? If the power required is greater than the power available, right? Your aircraft will start descending, or you can say start gliding. Say yes or no? Means
Right.
it cannot sustain, or it cannot maintain the same altitude. Is that clear or not? So means what? Your aircraft something like this. So you can write, this is nothing but you can say local horizon. Now, have you seen any landing? Hello? Have you seen any landing in real life?
Yes sir.
So the aircraft generally comes something like this, right? Are you getting what I'm saying? So
Right.
the flight path angle is a different thing. Okay. Are you getting what I'm saying? The flight path angle is a different thing, and the angle between the local horizon and FRL is a different. Is that clear or not? Check. Or you can relate these all things. You know, what is the best example to understand this one? That's a fevoid mode, right? Hello. Aircraft gains the altitude and then losing the altitude, right? Continuously. So in one time, its speed is decreases, reach to the minimum, then again it start descending. Okay, please go through that diagram. So here you can consider, let's say, okay, let's say this is the velocity vector v infinity. This is nothing but you can say your FRL. This is nothing but, let's say, it's a CG. So the lift always acts normal to this one only, L here. Okay, check. So this angle should be 90 degree. And then where is the drag? Drag is here. Now clear, Simran? Are you there? And
Yes,
where is the
sir.
weight? Weight is here, vertically downward, right? So if we extend this further, right? So this angle is what? This angle is exactly equal to this angle. So you may, if suppose if you're considering it's a gamma, but please take care it's a glide angle. So this angle is also gamma. Is that clear? Hello, am I audible or not? Hello, am I audible?
Yes sir.
Yes, sir.
Now, so what is the angle of attack here? What is the angle of attack? I'm just saying this is nothing but you can say wing of your aircraft. So this is the angle of attack alpha. Check please. Right? Hello? Am I audible or not?
Yes, sir.
Okay. Now draw a line through this CD, something like this. So this line is parallel to this line, means it's a local horizon, right? Check please. So what is the theta here? Check. What is the theta? You can calculate. Am I audible or not?
Yes, sir.
Let's take care of this diagram. Now, look at this question number 14. A conventional low-speed aircraft and the following aerodynamic characteristics: CD naught is equal to 0.002, E is equal to 1.0. The aircraft was flown to maintain a steady level flight for minimum thrust required at a lift coefficient of CL is equal to 0.8. The numerical value of aspect ratio of the wing is round up to 3 decimal places. It's a GATE 2017 question for 2 marks. So right now, what is given here? You can write flying under minimum thrust required condition. Check please.
Yes, sir.
So what
Yes,
is your minimum thrust required condition? You can see your minimum TR minimum is nothing what you can say D minimum condition, right?
Yes, sir.
Or you can write it corresponds to your LYD max condition. Say yes or no? Okay. So what the data is given here? First you have to write down CD naught equal to how much? It is given 0.02. How much? 0.02. Then small e equal to how much? 1. So which wing plan form is this? If the span efficiency factor is equal to 1, can you tell me which wing plan form is this? You can say it's a elliptical.
Electrical.
For which wing plan form we are having the minimum induced drag coefficient? Rectangular wing, tapered wing, or elliptical wing? For which wing plan form we are having the minimum value of CDI? CDI is equal to CL square upon pi here, right? So if the E
Yes.
value is 1, it means that what? You can say the CDI value is maximum. If you are means comparing the plan form, then only, right? Now let's solve this question. You are seeing CD naught is given 0.02, E is 1.0.
Sir.
Yes, please.
Sir, for elliptical plane form, CDI will be minimum only, no?
Yeah. What I said? Did I said maximum?
Maybe I thought yes.
Okay, no. E equal to 1. Then for this elliptical wing plane form, CDI rectangular, or you can say the tapered. Okay, check. Maybe please
Yes.
take care. Please take care. The CDI is less, or you can see some minimum for you can see elliptical plane form. Okay, if suppose it's a rectangular or you can say other one, then definitely the value of E is lesser than 1 for all the wing plane form except elliptical. But sometimes during the design phase we are having one tapered ratio, okay, for which this E value is very near to 1. So we generally consider, or generally we take that particular taper ratio wing. Now let's solve this question. What they are asking, the numerical value of the aspect ratio of the wing. Okay, aspect ratio of the wing is required, right? Okay, let me change. So for LYD max or TR minimum, what we can write? CD naught equal to CDI, right? Check.
Yes, sir.
Hello, am I audible? Now, from here, the CD naught equal to K times of CL square. Say yes or no?
Yes, sir.
That's the condition. Now, in this case, the value of CL is given in this question. The value of CD naught is also given, right? Can you calculate what is the value of K? Simply
Yes,
it's the
sir.
CD naught upon CL square. Agree or not? Check, please. Now,
Yes, sir.
so calculate what's the value of K. CD naught is given how much? It is given 0.02, right? 0.02 divided by what's the value of CL square?
0.8.
0.8. So you can write it's a 0.08 or 0.08. Please verify 0.8, right?
0.8.
You can write it's a 0.8 square. So what's the value of K? Please calculate.
0.03.
0.02 divided by 0.8 square. How much you're getting?
03125.
0.3125, right? That's
Yes,
what you are
sir.
getting?
Yes,
Okay.
sir.
Now, what is the value of K? K is equal to 1 upon pi EAR, right? Check.
Yes, sir.
Is equal to what? 0.03125, right? So from here, being plane form area is given in this question. What they're asking? Being plane form area or aspect ratio? Aspect ratio they're asking, right?
Aspect ratio.
Okay. So from here, how to calculate? You can write aspect ratio is equal to how much?
1 upon pi E into K.
You can write here 1 upon 0 point, right? 03125, please verify.
Yes, sir.
Yes, sir.
Into pi
Yes, sir.
into E. So
Yes, sir.
aspect ratio is nothing but E is how much? E is 1.
1.
Okay. So you can put here directly. How
Yes,
much
sir.
you get?
10.18.
10.8591.
1 divided by answer. 10.1859 something are you getting?
Yes, sir.
Yes, sir.
Yes, sir.
10.18591636, right? Up to how many decimal points they are asking? Up to 3 decimal places, right? So look here. How to take this answer up to the 3 decimal point? If suppose it's a 5 or more than 5, then we have to add to the next digit, right? So it's a 6. Okay. 1, 2, 3, 4, 5, 6, 7, 8. How many digits are there? 1, 2, 3, 4, 5, 6, 7, 8, right? If suppose if you want to write up to the 7 digit, okay, up to the 7 decimal places, then we can write it's a 10.1859164, right? If suppose if you want to write up to the 6 decimal places, then this 4 is what? The 4 is lower than 5. It means that what? You can neglect this particular value and we can write directly 10.185916, right? Again, if suppose if you want to write up to the 5 decimal places, then obviously it's a 6, right? Then we have to add 1 digit here. Then it's a 10 point, it's a 6th class or 7th class mathematics only. Then it's a 2. Again, if you want to write, then obviously nothing you have to add here because this 2 is lower than 5 only, right? So 10.1859, it's up to the 4 decimal places. And if suppose if we want to write up to the 3 decimal places, then 10.18, you have to add 1 here. So simply what you can write? 186. That's our aspect ratio. यहाँ पे बहुत मिस्टेक करते हैं बच्चे. Is that clear or not? We are getting 10.186. So the answer is given here 10.002 to 10.500. Means what? Our answer is correct. Say yes or no? Hello?
Yes, sir.
Now next question. An aircraft with mass of 4,000, no, 40, how much is there? 4 lakh kg, right?
4 lakh.
4 lakh kg. Cruise at 240 meter per second at an altitude of 10 kilometer. Okay. It's a lift to drag ratio at cruise is 15. Very good. Assuming G is equal to 9.81 meter per second square. The power in megawatt needed for it to cruise is what they are asking. See, the previous question was what? The power was given, right? The power required was given, and they were asking like what? What is the value of LYD ratio, right? In this question, you can see you can see very similar question. In this question, they have given the LYD ratio, and simply they are asking like what? They're asking what is the power required in megawatts here. Can you calculate? Very easy. How? First of all, the weight is given converted into the Newton only. So it's a 400 into 9.81. Can you tell me how much you're getting? Weight?
Sir, 3924. 3924.
3924.
2400.
This one, please verify.
Yes, sir.
Yes, sir.
Sure.
Yes, sir.
Okay, that's a Newton. Okay, then cruise speed is given how much? 240. So V is given 240 meter per second. How much? 240 meter per second. They are saying this aircraft is flying at 10 kilometer altitude. How much? 10 kilometer. So you can consider, let's say this is the aircraft, okay, having the forward speed V infinity, flying at h equal to 10 kilometer from the mean sea level. H equal to 10 kilometer. Okay. Lift to drag ratio at cruise is 15. So during the cruise, this LYD ratio or the CL by CD ratio is given how much? 15. Okay. The power required or power needed for it to cruise is, can you calculate? Hello? What is required?
Yes, sir.
Weight is given, L by D ratio is given. Calculate what is the thrust required. Thrust required is equal to W divided by L by D. Check the Y during the cruise. So weight is given 3924,000 divided by L by D ratio is how much? 15. Can you tell me what is this value? Hello? Then just calculate power required is equal to thrust required into the forward speed of the aircraft. Why I am writing the thrust required? Hello? Because the power required is equal to the drag into the forward velocity. And during the cruise flight, we can write the thrust required is exactly equal to the drag, or you can say drag is exactly equal to what? Drag is exactly equal to thrust required, right? Hello? Am I audible or not?
Yeah.
Check, please. So now we can write, what is this value? Can you tell me, please?
Sir, 261600.
Yes, Simran.
So
How much?
2616.
2616
26
00.
Come again?
2616
Huh?
00.
00. Yes, sir.
What? Gadya, Gode. What's the unit?
Newtons. Newton.
Newton, sir.
261600 into what's the forward speed?
240 meter.
240.
Just calculate and let me know what is this power required value.
62.784
megajoule.
Just,
Yes,
just
sir.
how much? 60?
62.784
78
784.
kilowatt or megawatt?
megawatts.
Megawatts.
Megawatt. Okay. What's the answer? 62 to 63.50, right? It means that what? Our answer is in the range, right? Now, again, write down this question. An aircraft with a gross weight of 2000 kg has a speed of 130 meter per second at sea level, where the conditions are 1 atmosphere pressure, 288 Kelvin temperature, and 1.23 kg per meter cube density. The speed in meter per second required by aircraft at an altitude of 9,000 meter, where the conditions are 0.31 atmosphere, 230 Kelvin, and 0.47 kg per meter cube to maintain steady level flight. It. Yes. Anyone? You are saying, let's say, try to understand this problem. Okay. Let's set the V infinity. Okay. Here h is equal to, consider it's a mean sea level, right? Where h is equal to at what altitude? 9 kilometer. Please verify.
Yes,
Hello.
sir.
Same aircraft is flying. Okay. And what they're asking? Okay. Okay. Just wait. The speed required by the aircraft at an altitude of 9,000 meter, that's nothing, 9 kilometer, where the conditions are okay. So they're saying at 9 kilometer, like the pressure at 9 kilometer is nothing but you can say 0.31 atmosphere. Okay, temperature at 9 kilometer is given 230 Kelvin. Density at 9 kilometer is given 0.47 kg per meter cube, right? At mean sea level, what is given? The density is given here. Density at sea level is given 1.23 kg per meter cube. That's ambient conditions only. Pressure is how much? So 1 atmosphere. Check please. 1 atmosphere only. Then temperature is given here like what? 288 Kelvin. How much? 288 Kelvin only. Now they want, if the aircraft is flying at mean sea level with a speed of how much? Tell me. At 130 meter per second. How much? 130 meter per second. And can you calculate like what is the speed of this aircraft if the pilot wants to fly at 9 kilometer altitude? How to calculate? Anyone? How to calculate this value? Look, at mean sea level, your true airspeed as well as you can say your equivalent airspeed are same. Say yes or no first of all.
Yes, sir.
Why? Give me the reason. Tell me why. What's
Because
the reason
density is
behind it?
relative density is
Because
1.
yeah, very good. Because the relative density is what? You can say 1 only. What is the relative density? You can write sigma u equal to rho h upon rho sea level, right? That's a relative density you are having. Relative density. Now, here, what is the relation? You can write true airspeed equal to equivalent airspeed divided by what? Root of sigma. So at sea level, what happens? If suppose h is equal to 0, this ratio becomes what? You can say rho SL divided by rho SL. So you can write this value is equal to 1. So this is the, you can say the unique altitude, right? Where you can see your true airspeed and equivalent airspeed are same. Is that clear? But here, if suppose if you want to relate or if you want to calculate what is the speed of this aircraft at 9 kilometer altitude, then can you calculate here? Just apply the relation Vt equal to V upon root sigma. You will get the answer easily. Hello, am I audible?
209.87.
How much you are getting?
209.8758.
29?
209, sir. 209.
Okay, 209.
0.87.
209. Okay.
0.1.
Okay. How much you are getting?
209.875849.
87?
58
58?
498.
49. Okay. So you can write Bt equal to how much? 209 point up to how many decimal? Up to how many decimal places they are asking? Up to 2 decimal places, right? So you can write it's a 209.88 meter per second. Can you verify this value? I'm not going to solve it. It's very easy. Bt equal to V divided by root of sigma. That's it. Hello. So calculate like sigma equal to what? You can write rho h upon rho SL. So what is the density at an altitude of 9 kilometer? It is given here 0.47. So 0.47 divided by 1.225. Then calculate what is this value, please. Hello.
So it is given 1.2, not
Okay,
1.25.
take the root of that value, and here this speed is given 130. So 130 divided by root of that particular value. How much you are getting? Please verify. Are you getting this one or not?
Yes, sir.
Yes. Any doubt?
So it is exactly coming 210.303732.
पवन क्या चल रहा है?
Sir.
हाँ? नंदिनी मैं बहुत डांटूंगा अगर तुम्हारा गलत हुआ तो ध्यान रखना इस चीज का. Is that clear or not?
Yes, sir.
एक सिंगल क्वेश्चन मैंने दिया आप लोगों को करने के लिए कैलकुलेशन के लिए, उसमें आप लोग मिस्टेक कर रहे हो।
Sir, her answer is correct, sir.
हाँ
Her answer is correct, sir. I took density as 1.225. I haven't
okay,
checked.
but it is given 1.225, no 1.23, right? It is
Yes.
given 1.23. Okay, so please take care of the given data. Okay, you should have to use the values which is given in the question. Don't assume from your side. Yeah, if any data is missing, or you can say it is not given at mean sea level, then you may consider it may, even if you take the one, then there is no harm. If you are taking it's a 1.22, no issue at all. If you are taking it's a 1.225, no issue at all. If you are taking it's a 1.2256, you can take any value. Okay, am I audible or not?
Yes, sir.
Okay, next question. But let me tell you one thing. Hello, am I audible or not? Let me tell you one thing here. Like what? Take it as a homework. Are you getting? What is this speed? You are getting the answer, it's okay. Hello? But this speed is how much? 130 meter per second. So the flow is compressible or incompressible? Hello, Maharaj. The flow is compressible or incompressible?
Compressible, sir.
How to calculate?
Sir, greater than 100 meter per second.
It depends on the temperature also, na?
Yes, sir.
So if the Mach number is higher than 0.3, what happens? The flow becomes compressible. So here just calculate how much you're getting. Okay, take it as a homework. Then please follow the approach which we have followed during the live lectures, right? If your speed is higher than, or you can say the Mach number is greater than 0.3, then the approach is quite different, right? See yes or no first of all.
Yes, sir.
Okay, so please go through my notes. You're getting the answer, no issue at all. But you should have to know like how to solve these kind of the questions means in a proper way or in proper manner. Now, next question. A pitot crew on an aircraft in a steady level flight records a pressure of 55,000 Newton per meter square. The static pressure and density are 45,200 Newton per meter square and 0.6 kg per meter cube respectively. The wing area and the lift coefficient are 16 meters square and 2 respectively. The wing loading on this aircraft is, again they are asking, what is the wing loading? That's a W upon S, right? Check. Look, let me tell you one thing. If you solve this question, okay, just by putting P naught minus P is equal to 1 by 2, okay, rho B square. Am I audible or not? Then you will get exactly this particular value, 19440.0. Hello, am I audible or not? Am I audible to you? What I'm saying?
Yes, sir.
If suppose if you are applying here, what is this? P naught minus P equal to half rho B square. This is nothing but you can say B equation. What is B equation? It's the Bernoulli equation only, right? We are taking the total pressure is nothing but you can say static pressure plus dynamic pressure half rho B square, right? But here we do not know like whether the flow is subsonic or you can say incompressible or you can say the compressible subsonic flow. Is that clear or not? Means whether this Mach number is less than 0.3 equal to 3 or higher than 0.3. Clear? Check please. Is that clear?
Yes, sir.
So what I'm saying, even if you are applying here directly Bernoulli equation, and if you solve correctly, you will get 19440. But if you follow the proper method, like P naught by P equal to 1 plus gamma minus 1 by 2 m square, then you will get the value means much lower than this 19,440. That's what I want to convey at this point. If you don't believe me, you can solve it. Is that clear? So first of all, it's a pitot probe. So what is the function of the pitot probe? This pitot probe generally measures the total pressure. Are you agree? Check please. So reading of this pitot probe is nothing but you can say P naught equal to how much it is given? 55, or you can write it's a 50,000 Newton per meter square, right? Check. The static pressure here is 45,000. Sanjeev, are you there? 45,280 Newton per meter square. Okay. And density here is given 0.6 kg per meter cube. Is that clear? The wing area and the lift coefficient are 16 meters square and 2. So here the wing area is given capital S is 16 meters square and CL is given 2. Now they are asking what is this WIS ratio, wing loading, right? Is that clear, those? Calculate कर. So knowingly they have given this density value, right? So if you want to calculate, you can, no issue at all. You will get this value. If you don't believe, okay, let me solve it. P naught is how much? It's a 55,000, right? Check. Minus P is how much? It's a 45,280, which equal to 1 by 2. What's the rho value? It's a 0.6, right? Into B square. Calculate what is the value of B from here. Anyone?
180.
Exactly, right?
Yes,
Yes,
sir.
sir.
180 meter per second. Once you know the value of B, what you can calculate? The aircraft is in steady state and level flight, right? Hello? Am I audible or not? Hello? Am I audible or not?
Yes,
Yes,
sir.
sir.
Now, how to approach this question? How to calculate? Just draw the diagram. That's it. Apply here. In the steady state and level flight, this aircraft is flying at 180 meter per second, right? During the steady state and level flight or cruise flight, your weight is exactly equal to the lift and your thrust required, or you can say T is exactly equal to drag here, right? So if you are putting L is equal to W, you know very well what is this L? It's a 1 by 2 rho infinity V infinity square, right? S into CL is equal to W. Is that clear, Maharajji? Hello? Check.
Yes,
So
sir.
from here, can you calculate what is the value of WIS? It's 1 by 2 rho infinity V infinity square into CL. Check करना थोड़ी. Hello? Is it correct or not?
Yes, sir.
By internet connection, I think it's a fluctuating, so please take care. If it is not means audible to you, please let me know. Okay. So WIS is equal to 1 by 2. Rho value is how much? Tell me what is the rho value? 0.6. V infinity is 180 square, right? Khushi, are you there? Khushi Moda? Khushi Manbao? Khushi
Yes.
Shoni? Okay. Calculate this one and let me know how much you're getting this being loading. WIS.
19440.
Right? That's the exact value you will get. Please verify, okay? Clear? Now, second approach is what? Second approach is something like this. You can apply here the asymptotic relation P naught by P is equal to 1 plus gamma minus 1 by 2 m square, right? Check. This power how much? Gamma upon gamma minus 1 for air, take gamma is equal to 1.4. Then what happens? This gamma upon gamma minus 1 becomes what? How much? Yes,
3.5.
only, right? 1.4 divided by 0.4. So how much? It's a 7 by 2, which is nothing but a 3.5. Just put these values, like what is the value of P naught? Can you tell me please? What is the value of P naught here? It's a 55,000, right? 55,000 divided by what is the value of P? It's a 45,280, which is equal to how much? 1 plus gamma is how much? 1.4. 1.4 minus 1 by 2 is how much? 0.2. 0.2 m square, or better write m d square. This power how much? 3.5. Just simplify it and let me know how much you're getting.
Sir, overall
0.13.
answer is 18109.43.
Sorry, come again.
Wing loading, overall wing loading through this method is 18109.43.
18
No, sir. 19440 exact.
for this one. It's exactly 19440. Please take care of this one. Yeah, you must have to write units, Newton per meter square. Yes,
To this
Pawan?
Mach number method.
Second method, na? Yeah, it
Yes,
is around 18 something like that only you will get, if I'm not wrong.
sir.
Actually, we have solved this
18109.
question during the lab lecture, right? Hello? We have solved this question. So just go through the notes. It's a revision class only. So how much you will get? Please calculate.
0.3448.
1.02 m in p square. U is equal to how much? What is this value? 55,000 divided by 45280. How much we're getting? 1.21 something? 1.2146643 raised power how much? 1 upon 3.5. Just simplify it and let me know how much you're getting. Or if I write, then I can write here m infinity square u is equal to how much? I can write how much you're getting. What is the Mach number you are getting? Okay, after simplification, please let me know.
0.534.
How much?
0.53448.
0.53448.
448.
Please verify this value.
Yes, sir.
Yes, sir.
So you can write m infinity is equal to 0.5345. Okay, check. Now, what do you know? The Mach number is always associated with true airspeed or equivalent airspeed. Yes.
True airspeed, sir.
True airspeed.
Okay. Mach number is always
ఎందుకంటే
associated
అక్కడ
with
స్టాటిక్ టెంపరేచర్ వాడుతున్నాం కదా, ప్రెజర్ వాడుతున్నాం కదా.
yeah. Okay. It is always associated with the true airspeed of the aircraft. So from here you
ఇప్పుడు
can
అక్కడ
write.
టెంపరేచర్ తో మల్టిప్లై చేసాం అనుకో దాన్ని.
Sorry, come again. What is it?
Sorry, sir, nothing.
M infinity is equal to V infinity divided by A infinity. Narsimha, are you there? Narsimha?
Sir.
Okay. So
Yes,
V infinity. Okay. So what we have to calculate? We have to calculate V infinity, right? So it's a M infinity into A infinity, right? Check. So calculate this V infinity is equal to what is the value of M infinity? It's a 0.5345, right? A infinity is what? You can write root of gamma RT infinity. Now look here. It's your choice. You can use C. We can take A is equal to root of gamma RT. Another formula is what? Root of gamma P by rho. How? You know, this P is equal to rho RT, right? That's the equation of a state. So RT is equal to how much? You can write it's a P by rho. So it's up to you. You can replace this RT is equal to P by rho, or this P by rho is equal to RT, or you can say as per the given data, you may use this formula. So either you can write it's a gamma RT infinity, or since the value of density is given, right? The value of pressure is given. So no need to calculate what is the temperature. You can use here. Can you tell me what's the value of B infinity you are getting? So 170 something or 176. How much you are getting?
173.73.
Sorry, come again.
173.735.
173.735
735.
meter per second. Are you getting this value? Please verify.
Yes, sir.
Okay. Now again, applying the steady state and level flight, lift is equal to weight half rho infinity V infinity square into S into CL is equal to W, right? Just calculate what is this W by S. So this W by S is nothing but it's a 1 by 2 rho infinity V infinity square into CL. Now, Kushi, 1 by 2 rho infinity is how much? Please tell me.
0.6.
0.6. Sorry, V infinity is how much? 173.735. Parshab Mahaprabhu, hello, are you there?
Yes, sir.
सो रहा है क्या तू उधर पे? हाँ. CL is how much? What's the lift coefficient? It's a 2.
2.
Akash, Ashish कहाँ है? Hello, Ashish. Are you there? Call करता हूँ मैं तुझे. रुक अभी. So W by S is equal to how much you will get? Please let me know.
1810.311014.
How much? How much? 1 8
18
huh?
110
110
.31014. 0.31014.
Please verify this value.
Sir, 0.476.
Sorry, come again. 18110.
Yes. 0.476. तो point के बाद अलग आ रहा है.
Okay, no issue. 18110.4
76. Yes. Sir.
Okay, it's a very near. What is the range? 18,000 to 19,000 to 19,440, right? It means what? Both the answers are correct. You will get correct value. Next question. For an airplane flying in a vertical plane, the angle of attack is 3 degrees. The horizontal and vertical component of velocity in wind axis are 30 km per hour and 15.72 km per hour respectively. The pitch attitude of the airplane is. Hello, am I audible or not? Just they are asking what is the pitch attitude. What if you see vertical plane? Hello, the aircraft is in horizontal plane, then it is something like this. Even it is cruising, then it is in horizontal plane or in vertical plane. Hello, during the cruise flight or it is a steady state level flight, this airplane is in horizontal plane or in vertical plane. You can say it's a flying at constant altitude, right? If suppose it is turning, or you can say it's a coordinated turn, or you can say what we call level turn, right? Then it will be in the horizontal plane. But during the climbing, what happens? If the aircraft is climbing, then obviously it is in the vertical plane. Say yes or no. If suppose this is the aircraft, right? If suppose it is flying, then it is gunning the altitude, so it is in vertical plane. Which plane is this? Look, it's a vertical plane, right? Calculate. Very easy. That's a CG. Let's consider this is the local horizon. Okay. Hello, am I audible or not? Let's say this is the local horizon. Now here, this is nothing but FRL, or you can say X the axis of this aircraft, right? Now let's say the aircraft is moving in this vertical plane. Just a minute. This is the PG. It is something like this. Let's say it is moving along this particular path. Okay, Prabhuji. So here, this angle is nothing but if you draw the angle something like this. So this is nothing but again gamma, right? Say yes or no. And here, this aircraft, or you can say airflow, is coming something like this. Let's say V infinity. So this angle is what? Angle of attack alpha. This is what you can say. This angle. Hello, am I audible or not? Which angles are same? If this angle is gamma, then what is this angle? Hello, Prabhuji. This angle is also gamma. Say yes or no. If this angle is gamma, then this angle is also gamma, right? So this is nothing what you can say simply. It's you can say it's a climb angle, okay, or angle of climb. Clear? Find out what is the value of theta. Theta is equal to alpha plus gamma. Okay, but what is given in this question? You're saying the angle of attack is 3 degrees. Okay, alpha is equal to 3 degrees. Here you can write alpha is nothing but 3 degree. Okay. The horizontal and vertical component of velocity in wind axis are 300 km per hour and 15.72 km per hour respectively. The pitch attitude of the airplane is very easy. Look here, what you can do. Let me help you. Look, let's consider this is nothing but you can say flight path. Okay, it is moving with some forward speed of b infinity, right? Check. Now it is having the two components. One is what? Horizontal velocity. Another one is nothing but you can say the vertical velocity. Can you draw here the velocity triangle? Hello? Can you draw here what velocity triangle for this climbing flight? Yes, we can. Right? Check. The horizontal and vertical. So horizontal velocity is given, it's a 300 km per hour, right? 300 km per hour. And this is how much? Can you tell me? Hello?
15.72.
15.72 km per hour, right? Now consider this angle is nothing but equals gamma. Can you calculate what is the value of tan gamma from here? Or can you connect? See what is known to us. Known to us, you can see the vertical component of velocity and horizontal component of the velocity, right? Meaning what? You can calculate what is the gamma. Tan gamma is equal to what? How to calculate tan gamma? You can see perpendicular divided by base. So you can write that's nothing but just a minute. You can write it's a v suffix b here. And this is nothing but you can see b suffix h. And that's nothing but you can see b infinity. If you want, you can calculate, no issue at all. So it's a bh, sorry, vv divided by bh. Tan gamma is equal to how much you're getting? 15.72 divided by how much? 300. Can you tell me what is this value?
Yeah.
Gamma is equal to tan inverse of 15.72 divided by 300. How much you're getting? Please let me know first.
2.999.
2.999.
2.999 times of what?
995.
3 times 9?
555. Yes, sir. And 5
Okay.
times 4 times 5.
Okay, so let's say this gamma is nothing but equal to 3 degree, right? Hello? Or even if you consider this one, they are asking what is the nearest integer, right? So if you are
Yes, sir.
going to calculate theta is equal to how much? Alpha plus gamma, right? This value is nothing but alpha is 3 plus 2.9995555. Then obviously your nearest integer is how much? You can write 5.9995555. So it leads to what? Theta is equal to, you can see 6 degree. That's your nearest integer. Check please. Am I audible or not?
Yes, sir.
Okay, next question. Yes. What is given? Consider a conventional subsonic fixed wing airplane. E is the Oswald efficiency factor and AR is the aspect ratio, corresponds to minimum CD upon CL raised power 3/2. What do you mean by CD upon CL 3/2 minimum? Means what? Huh?
Minimum power condition.
Minimum power condition.
Power
That's nothing
condition.
what you can say. Minimum power condition, or what you can write? It corresponds to what? CL raised power 3/2 divided by CD max. Check. Hello? Both
Yes,
are
sir.
same
Yes,
thing,
sir.
no? So this corresponds to what? It corresponds to minimum power condition, right? So what it means by minimum power condition? Look, CD naught equal to CDI. This is nothing what you can say minimum drag, right? It's a minimum drag condition. Now, what is the minimum power? One we are aiming CD naught equal to 1/3 of CDI, right? Another one is what? CD naught equal to 3 times of CDI. Now, which one is this? Yes, CD naught equal to 1/3 of CDI means what? It is
Minimum
minimum DYV ratio or minimum power condition.
Minimum
Huh?
power.
Minimum power. You can write this is nothing but you can say minimum power condition, right? And this is what generally we call minimum DYV.
Drag.
DYV means drag to velocity ratio. So where it is required? During the range and endurance of piston engine aircraft or jet engine aircraft. Yes. Sleeping. Hello. What it means by this minimum DYV ratio? What it means that ultimately CL raised power half divided by CD. Hello, am I audible?
Yes.
Yes, sir.
This ratio means what? You can say in this case your CL upon CD is max, right? Check please. Corresponds to this your CL raised power 3/2 divided by CD max, right? And corresponds to this what? You can say CL raised power 1/2 upon CD max, right? Please correct me if I'm wrong. Hello. Please
Correct,
correct me if I'm wrong.
Correct, sir.
Correct? Okay. Because I'm taking some doses nowadays like medicine. So sometimes, I'm unable to recall the things properly. Okay, so please take care. Check. Now, so which condition is this? It is a minimum power condition, right? So minimum power condition leads to what? CL raised power 3/2 upon CD max, right? Or CD upon CL raised power 3/2 CD minimum. Say yes or no?
Yes, sir.
Now, what is the condition? You can write CD naught equal to 1/3 of CDI. Check, please. Now, what is the CDI? The CDI is nothing but it's a KCL square. Check, please. Right?
Yes, sir.
Simplified. So you can write CD naught equal to 1/3 of KCL square. So from here, what they're asking? Okay, CD upon CL square. Okay, calculate. CD is given by CD naught plus KCL square, right? Check, please.
Yes, sir.
Or you can simply write CDI, right? Check. So shall I put here CD naught equal to 1/3 of KCL square in this equation in drag bull-up? So CD equal to CD naught is how much? 1/3 of KCL square, which is nothing but 1/3 of CDI. Check kari thodi. So it's a 1/3 of CDI plus CDI, right? So ultimately, what you can write? The CD equal to 4/3 times of CDI. Say yes or no?
Yes,
Now
sir.
again, the CD equal to 4/3, right? Into CDI is how much? CL square upon pi ER. Check kar chori. Now what they're asking, CD upon CL square is how much? So take the CL square to left hand side. So ultimately you can write it's a 4 divided by 3 pi ER. Check kar you. Please check.
Yes, sir.
So which is the correct option here? Option B, 4 divided by 3 pi EAR, right? So option B is the correct one. Okay. Check, please. Now, these are the most important questions, and you should have to complete this one. Hello, am I audible or not?
Yes,
sir.
sir.
Look, you can solve this question, by 5 methods. How many methods? By 5 methods. And what is the problem with these students? Please don't mind, but that's a reality I've seen in the university. The main problem with the students is that they are busy, but they are doing nothing. Are you agree or not? They are the most busiest creature, okay? But in reality, they are doing nothing. And I don't know whether you believe or not. Now, can you calculate B max and B minimum here? Can you calculate? Simran, are you there? It's your topic.
Yes, sir.
Are you there? हाँ.
Yes.
बता कितने मेथड से तेरे को सीखना है, उतनी मेथड में बता दूंगा. How many methods you want to follow?
एक ही जो आपने क्लास में कराया था.
ओके. और कुछ हो सकता है? Okay, let's start with this question. We are saying data for an airplane are given as follows. Weight is given, W is equal to 30 kilonewton. Thrust available at sea level is 4000 Newton. Wing platform area is 30 meters square. Maximum lift coefficient CL max is 1.4 and drag coefficient is this much. Assume air density at sea level is 1.22 kg per meter cube. Stall speed of the airplane in meter per second. So can you calculate what is the stalling speed? The stalling speed of the aircraft is corresponds to what? Corresponds to, yes, CL
Maximum
max,
CL.
right?
Maximum.
So, and can you define what is the stalling speed of the aircraft? Yes, please. What is the stalling speed? Yes, it is the lowest or minimum speed of the aircraft at which it can fly without losing its control, right? It can fly in a steady state and level flight without losing its control. Clear? Just apply. So you know very well this B stall corresponds to the CL max during cruise, right? So what you can write here? You can write during steady state and level flight L is equal to W. If you simplify it further, what you can write 1 by 2 rho infinity B infinity square S into CL is equal to W. If you simplify it further, what you can write? You can write B infinity is equal to, or B is equal to, simply you can write root of 2W divided by how much? Yes, anyone? Rho infinity into S into CL, right? Now, WYS is what? This WYS is nothing but it is a wing loading. So it's a design parameter that's constant, right? So during the design phase only, you have decided this one. Now, rho infinity is what? You can say that's an ambient density that depends upon for what altitude you want to design this particular aircraft, right? Or even the value of rho is keep on changing during the flight altitude, or you can say as the altitude increases from mean sea level to, you can say the cruise altitude of a particular airplane, right? Or for example, if you talk about, you can see the tropopause. What is the density at tropopause? 0. Yes,
36. 0.366.
0.236 or 336 or 366?
3636.
3636, right? That's the correct one. So the density at tropopause, density at 11 kilometer is 0.3636, right? Kg per meter cube. So as you can see, like we can write this B stall equal to, even very similar question they have asked in MSQ type, rho infinity S into CL max, right? Check please. Now, what you can observe, what you can observe from here, if the weight of the aircraft decreases, then the stalling speed increases or decreases. Look here, your B stall is proportional to the weight. root of this, your V stall is proportional to this particular value. Your V stall, again, if you want to write in terms of the wing loading, then you can write it. Let's consider small w equal to WYS is nothing what you can say, wing loading. So you can write it's a small w. Then if you want to write, then you can write here V stall is again proportional to root of CLmax. But can you increase the value of CLmax further? Hello? Yes, we can. With the help of what? With the help of the flaps, right? During the time of, and particularly, you know, during the time of landing, right? You can say the CLmax value, or you can say the deflection of your flaps are maximum, right? If you compare the takeoff phase and landing phase. So during the landing phase, your flaps are much, you can say deflected, or you can say they are deflected downward, something like this, or you can say highly downward deflection compared to what? Compared to your takeoff conditions. Even if suppose it is installed with the leading edge flaps, then again we have to increase this leading edge flap also, right? So we can further increase the value of CLmax with the help of, generally we call it's a auxiliary devices, right? Auxiliary devices or high lift devices, right? Then it's the wing loading. So if the wing loading is increases, then stalling speed increases. Then rho infinity, you know very well. As the altitude increases, then the ambient density decreases. If the ambient density decreases, then your stalling speed is again increases or decreases with increase in altitude? Increases, right? Hello? Am I audible or not?
Yes, sir.
For example, the density at sea level is how much? You can say it's a 1.2256 kg per meter cube. Check please. And the density at 11 kilometers is how much? 0.36 kg per meter cube. So if you want to compare, like, then what you can write for the same wing loading and same CLmax value, right? If you are keeping, if suppose if the pilot want to fly this airplane in steady state level flight, okay, at sea level as well as at proper pause, or you can say 11 kilometer altitude, right? Then which stalling speed is higher? Or can you write the V stall at sea level is greater than the V stall at 11 kilometer altitude by keeping all the parameters same, or V stall at sea level is lower than the V stall at 11 kilometer? Which one is correct? Option A and option B. Please comment in chat box, those who are online, or you can say those who are watching live on YouTube. Yes, which one is correct? Your CLmax value is same. Okay, you can keep your wing loading is also same. Okay, at both the altitudes. Just only the altitude of this aircraft is means changing. Then what happens? Which one is correct? Option A or option B? Common sense is not so common. What happens?
B.
That if the density decreases, then your stalling speed increases, right? It means that what? The stalling speed at 11 kilometers is higher than the stalling speed at mean sea level. Am I audible or not? Even if
Yes,
you
sir.
look at this thrust required and thrust available curve at different altitudes, then the intersection of the thrust available and thrust required curve is what? Is keep on increasing. And if you take the coordinates on this velocity axis, or you can say speed axis, then what you can see or what you can observe, your stalling speed, or you can say the lowermost intersection of your thrust available and thrust required curve, what happens? It keep on increasing, or you can say your stalling speed increases. Say yes or no? Are you getting?
Yeah.
That's it. Okay. Even your stalling speed is decreased during the time of landing, because because of the consumption of fuel also. The total weight of the aircraft is how much? W naught equal to, let's say I'm considering WE is nothing but you can say empty weight, including the passenger's weight, or you can say the payload weight, or you can say pilot and crew all are including, and this is nothing but you can say weight of fuel. So during the flight, the weight is consumed So which weight, or you can say which mass is consumed? That's a weight of fuel only, right? Say yes or no.
Yes, sir.
It's not a fighter aircraft. We are not dropping any payload, right? So it means that what? Your W naught is decreases as the fuel consumption takes place, right? So if you look at this particular formula, your stalling speed during the time of landing is lower than what? Lower than the takeoff. Or if you want to land, why? Because your weight is what? Your weight is decreases, or you can see your wing loading is decreases. Decrease because of what? Because of the consumption of the fuel, right? Check. Just calculate this question. It's very easy. You can write here V stall is equal to root of 2W divided by rho infinity S into how much? CL max. Check. Calculate. V stall is equal to how much? Root of 2. What is the weight of this aircraft? It's a 30 kilonewton. So you can write it's a 30 into 1000 divided by how much? Rho infinity. So what is given here? Any value of rho infinity is given? Yes, 1.22 is given. S is given how much? What is the value of capital S? It's a 30, right? Check. Then CL max value is given 1.4. So if you simplify it for the, what you can write? This 30 and this 30 is get cancelled. So V stall is how much? Your start speed is nothing, what you can say? 2000 divided by how much? Tell me please. 1.22 into 1.4. How much will get? Please let me know. Yes, how much you're getting?
34.2192.
4.219.
V stall is equal to, if you simplify it, how much you're getting? 34.
34.219.
219 meter per second, right? That's it. So option B is correct. Okay. Now, this question is very important. It's the most important question, or conceptually I'm saying, okay. They have asked this maximum speed, minimum speed, or you can say maximum thrust so many times in your GATE exam. Okay. Let's start with this problem. Please write down. Okay, shall I ask you few things here? Hello, am I audible?
Yes,
Shall I ask you? Okay. In case of cruise flight, how to write the thrust required, or you can drag? The total drag is how much? D is equal to parasite drag plus induced drag, right? Check. Agree?
Yes, sir.
Your total drag, capital D, U is equal to parasite drag plus induced drag, right? So that's what I have written here. Clear? Now here, this D is equal to, what is this dP? Anyone? What's the value of dP? 1 by 2 rho infinity, or simply you can write 1 by 2. Yes, anyone? Rho S CD naught, please verify whether this is correct or not. क्यों रे गेट एग्जाम तुमने लिखना है या मुझे लिखना है? हेलो, am I audible?
Yes, sir.
हाँ, रिवीजन नहीं किया है क्या तुम लोगों ने? dP is equal to 1 by 2 rho S CD naught into how much?
V
V
square.
square.
Okay, what is induced drag DI? Yes,
KW square
KW square divided by 1 by 2 rho infinity into S, right?
into
Bracket
B
close,
square.
1 upon B square, right? Check.
Yes, sir.
Yes, sir.
Please let me know if I'm wrong. Okay. KW square, is it correct? Is it correct or not?
Yes, sir.
Yes, sir.
Okay. So what we have taken? We have taken this is capital A, right? And we have taken this value is nothing but you can say capital B, if I'm not wrong, right? The total drive, if you want to write, this is nothing but 1 by 2 rho S CD naught, right? B square plus 1 by 2 into KW square divided by 1 by 2 rho into S into 1 upon B square, right? So consider this is A.
1 by 2 नहीं आएगा.
Yeah. 1 by 2 we have already taken, right? Sorry. Now correct now? Hello?
सर वो सर एक तो 2 पर आएगा या फिर रो के पास 1 by 2 आएगा.
तो ये लिखा तो है? Oh
वो
sorry.
सर
Yeah.
ऊपर आप अलग लिखा.
Okay. Sorry. KW square. Now correct, right? Check. Or you can take this 2 in the numerator. Now correct, Khushi?
Yes, sir.
So you can write it's EB square plus B upon B square. Clear? Check please. Now, with the help of if the aircraft is flying, in a steady state and level flight, in which flight? Steady state and level flight, then it has to satisfy which condition? Thrust required is equal to drag and L is equal to W, right? Check. Agree? Now you know your V stall. Generally, we can calculate by taking L is equal to W. But how to calculate the maximum speed of the aircraft? Anyone? Yes, we have discussed in class also. Even in the beginning, or you can say in the introduction classes also, I already discussed a lot regarding this maximum speed, minimum speed, stalling speed last year. Yes. What's the condition for that? If you want to calculate what is the maximum speed of the aircraft, right? Then you should have to think in terms of what? In terms of, you can say the thrust available, or you can say in steady state and level flight, maximum throttle is what? If suppose, or you know where, again you can write your maximum speed is the function of, you can say, the capacity of the power plant and at what altitude this aircraft is flying. Why? Because the thrust available is decreases as the altitude is increases. How? Anyone? बता सकता है कोई? Because this thrust is equal to T is equal to mass flow rate of air. If I want to write here this thrust equation, it is how much? 1 plus F, right? Yes, what is the thrust equation? Anyone? Oh my God.
1 plus F E minus
1 plus
V.
F into V minus V.
Plus A into
A
P minus P, right? Check. Now, if suppose, if you are considering, let's say there is no pressure thrust, let's say it's 0, or you can say a P equal to PA, either the nozzle is unchoked, or if suppose it's a convergent divergent nozzle, then let's say it is flying at its design altitude, or you can say the nozzle is optimum, then you can write P equal to PA, so this pressure thrust terms is gone. And consider this F is what? You can say it's a much smaller than 1. Then you can write P equal to mass flow rate of air in bracket BE minus BA, right? So you know very well this mass flow rate of air is what? You can write it's a rho infinity, right? Means ambient pressure, then ambient density. Then what is the inlet area of this inlet, intake into what is the forward speed of the aircraft, right? So here this mass flow rate of air which enters through this aircraft engine, or you can say power plant, right, is what? You can say it is directly proportional to rho infinity. And now further, what you know from this atmosphere, you know very well this rho infinity decreases as your altitude as it increases. Say yes or no? Bol haan ya na? Agree or not? So it means that what? Your thrust available is decreases as the altitude of the aircraft is increases, right? Hello? Is that clear or not?
Yes, sir.
Now, this maximum speed of the aircraft, it depends upon like what is the capacity of the aircraft, or you can say what is the capacity of this power plant. Best example, if you are having CT100, right? Which bike? CT100, 100cc. Another bike, let's say if you are having any super bike, or let's say if you are having Royal Enfield, right? Which one is having the highest speed? CT100 or Royal Enfield? Yes.
Royal Enfield.
Why? Because the power capacity of that particular, you can say, vehicle is much higher than this CT100 bike. Am I audible or not?
Yes, sir.
So the maximum speed is depends upon the capacity of the power plant. Now, this machine, which one? This flying machine, or you can say air machine, is obviously it is flying in the atmosphere. So it also depends upon the ambient conditions, or you can say for what purpose, or you can say for what altitude you want to design this aircraft, right? If the altitude is increasing, okay, your drag is also decreasing, right? Am I audible or not? Your drag is decreasing. At the same time, your thrust required to fly the aircraft is increasing. But you know what your thrust available is also. Check please. 1 second. Your
Yes, sir.
thrust required is increases or decreases with increase in altitude? Yes, tell me. Your thrust required.
Increase.
Your thrust required is increases or decreases?
Increases.
And what about this thrust available?
Decrease.
Okay, and what about drag?
Drag will decrease overall.
Really?
Drag.
Go through the notes, okay? Go through the notes. And what about this TR value? Huh? TR value. W divided by L by D or L by D max. TR minimum is independent of the altitude. How many times I have to tell you these all things?
TR minimum is independent.
Yeah, that's what I'm asking. Your TR minimum is independent of the altitude, right? Clear or not? Now,
Yes.
here your thrust available is nothing but, let's say, is nothing but you can say drag, which in case of, let's say, T equal to D, which is nothing but half rho B square S into CD, right? Now, from here, if you want to calculate what is a B, then this is nothing but simply you can write it's a 2T divided by how much? Rho S CD. Clear? Now, so this B tends to B max when CD tends to CD minimum and T tends to T max, or which is nothing but you can say thrust available. Check. Clear or not? Am I audible? So here you can write this B max corresponds to twice of thrust available divided by rho S CD minimum. But common sense is not so common. Most of the students think this CD minimum is nothing but that's a CD under minimum drag. That's a common mistake most of the students and professors do in class. That's why they don't get the answer, right? So join AERO KAKA if you want to learn aerospace engineering. And even if you are not preparing for this GATE Aerospace exam, if you are having the craving for the knowledge, join immediately as soon as possible. Now, we can calculate in, again, we can write here this thrust available in steady state and level flight. If suppose the aircraft is flying at full throttle, then again, if you want to maintain the steady state and level flight, in that case also, you can write T equal to D is also possible, right? Check. Just calculate and let me know. Can you calculate? Yes, anyone? Or simply, this is the first method. hardly it will take, 1.5 minutes to find out what is the value of Bmax. But the problem with this method is that, yeah, you can also calculate B minimum, right? Hello, am I audible or not? You can also calculate what is the value of B minimum. And this is stalling speed and minimum speed are different. Am I audible or not? Your stalling speed and minimum speed may be same, may not be same, may be differ. For
Yes, sir.
example, if you calculate the stalling speed, we are getting around 34 something, right? But you can also calculate what is the minimum speed of the aircraft. If suppose this B minimum is lower than the stalling speed, then you can see the minimum possible speed to sustain the level flight is nothing but you can see your stalling speed. But there are some cases like where you can see your B minimum is higher than your stalling speed, then you should have to consider the B minimum. Your B minimum is nothing but you can see the minimum speed of the aircraft. Okay, am I audible? Please write somewhere. If B stall is higher than the B minimum, then minimum speed is how much? Yes, then minimum speed you can write B equal to B minimum. Okay, if suppose, meaning what's the meaning of B stall is greater than B minimum? That's nothing but you can say B minimum is lower than B stall, right? Check, that's a meaning. Now another case is what? If the B stall is lower than the B minimum value. Which value? B minimum value. Meaning what? Your B minimum is higher than the B stall value. Then generally we take the B minimum, B equal to B minimum. That's the lowest possible speed of the aircraft.
So
Oh,
V stall.
no, V stall. Sorry. Here it's a V stall. Sorry, it's a mistake. Sorry. Okay. If the B minimum is lower than the stalling speed, then your minimum speed, B minimum is nothing but you can say V stall. Okay. But here, if the B minimum is greater than B stall, then here B minimum is nothing but you can say B minimum itself only. Please take care of this one. Okay. But the question is that how to calculate this one. Subham, are you there? Question is that how to calculate this value. Anyone? Look, you know very well, thrust required is equal to drag is equal to AB square plus B upon B square. Check. Are you agree?
Yes, sir.
So simply I'm writing this thrust is equal to AB square plus B upon B square. Right? Check. Am I audible or not? Now, can you simplify it further? What you can write? You can write it's a TV square equal to AB raised power 4 plus B. Check. Again, what you can write? AB raised power 4 minus TV square plus B equal to 0. Check. Just apply Sridharachar and calculate what is the value of B. You will get two values. One is plus minus, another one is you will get B max, another one you will get B minimum. Can you apply? Hello?
So that can't
Can
be
you
V
apply or
minimum.
not? Huh?
V minimum
Yes,
depends
sir.
upon stalling speed.
Just a minute, just tell me what is this value. Hello? Just solve it with the help of Sridharachar and let me know how much you're getting. Just recall Sridharachar Mahaprabhu. Okay, apply it and let me know how much you're getting.
So Vmax 119.459.
No, I'm not asking the final value. Hello. Tell me in terms of this thrust values, in terms of A, T, and B.
So 0.2745.
No, I'm not asking, I'm not interested what you are getting. What I'm asking, just take the factors, just do the factors of this equation. Let me know what is the plus value and what is the minus value. Obviously, it's a minus B plus, what is the Sridharachar? AX square plus BX plus C is equal to 0. So how to calculate the roots? x is equal to minus b plus minus root of b square minus 4ac divided by 2a? Say yes or no?
Yes, sir.
Then just tell me how much you're getting. Take your time. You can find out, in fraction of seconds. No need to use the.
One is t plus root of t square minus 4ab by 2a.
क्या हुआ?
Vmax, sir.
How much you are getting?
T plus root of t square minus 4ab by 2a.
Very good. T plus root of
T square minus 4ab. Minus 4ab.
4ab
by
upon
2a.
2a.
whole divided by 2a, right? It's inside the
Yes, sir.
bracket, right? V minimum is how much? Root of.
T minus root of
Just
t
there
square
is a
minus
difference
4ab.
of this minus sign, okay? T minus root of t square minus 4ab divided by 2a. खुशी आ रही देयर? इसमें पुट करके देख, तुरंत से आंसर आता है. हेलो? So labor work थोड़ा कम करो आप लोग. Is that clear or not? The 6th class or 7th class mathematics is required to answer this question. ठीक है? तो नहीं आता है मैथमेटिक्स तो अपने छोटे भाई बहन को बिठा के साइड से रखा कर, रिश्वत देना स्टार्ट कर दे. कर रहे हो, आई नो वेरी वेल. चल भाई बताओ मुझे, हाउ मच यू आर गेटिंग? सो व्हाट इज गिवन इन दिस क्वेश्चन? द वैल्यू ऑफ टी इज गिवन, राइट? टी इज गिवन, टी इज इक्वल टू, it's a 4000 Newton, right? It's a 4000 Newton. Then Shimran, are you there?
Yes, sir.
हाँ, आ रहा है समझ में?
Yes, sir.
CL max is given how much? 1.4. Direct polar CD is how much? 0.015 plus how much? 0.024 CL square, right? Check. Rho infinity is how much? 1.22. Rho infinity is given here 1.22 kg per meter cube. Now, what is required? See, the T value is already given to you, right? Just calculate. You know what is required? Just the value of capital A and capital B. That's it. Is that clear? Calculate. What is capital A here? 1/2. Rho S CD naught, right? Check please. And what is the value of B? It's a KW square divided by how much? Tell me please. Divided by 1/2. Rho S.
1/2 rho into x.
That's it. Please let me know what is the value of capital A and capital B. Anyone? 1/2. Rho is 1 point. How much you are getting? 1.22. S is how much? 30. Into CD naught is how much? 0. So CD is equal to what? CD naught plus KCL square. Just compare this equation with the direct polar. You can write the CD naught is equal to 0.015, right? And the value of K is how much here? K is given 0.024, right? Check. 1.22. S is how much? 30. CD naught is how much? 0.015. Please let me know how much you're getting. Here, K is how much? Just wait. 0.024 divided by how much? 1/2. Weight of the aircraft is how much? What is the weight of the aircraft?
30 kilonewton.
30 kilonewton, right? We can write it. It's a 30 into 10 is power 3, right? Square. 1/2. Density is 1.22. S is how much?
30.
Yes, 30. Nikal de. Tell me what is the value of capital A and what is the value of capital B?
So capital is 0.2745.
0.2745 हाँ
और B का वैल्यू 1180
हाँ
327.869.
0.86. Okay, please verify this value. Are you
Yes,
getting
sir,
this one?
same.
Yes,
Same,
sir.
sir.
Yes, sir.
Exactly.
Okay, so each and everything is in front of you. So first calculate what is this value. Take the root. Put here. What is the capital T? Divide by 2a and take the root of the whole value. How much you're getting? Yes. V max is how much? And V minimum is how much? Yes.
So V
Take your
max
time.
119.45.
459, sir.
119.459
459. और
meter
V
per
minimum,
second.
yes sir.
Yes.
V minimum 17.358.
17.358 meter per second. Now, can you tell me what is your stalling speed? What is your stalling speed? V stall is how much?
34 point something.
4.219.
219. So up to
Yes,
2
sir.
point, right? 34.22 meter per second. So which case is this? In this case, your V minimum, right, is lower than the V stalling. So what is the minimum possible speed to sustain this
V
level
stall.
flight? You can write here your V minimum in this case is cannot be 17.358, but your B minimum in this case is how much? It is equal to V stall, which is nothing but you can see 34.22. Please take care of this constant. Okay. Am I audible or not?
Yes, sir.
Is it
Yes,
okay?
sir.
So no, why we are, or even see, generally in if suppose if you are doing the preparation of this PCS exam or UPSC, generally we use one approach. That's nothing what you can say elimination approach, right? So what is the elimination approach? Let me tell you. I think I have means already explained these all things in live lectures. For example, if you know one of the answer, right? You are sure. Like, look at this minimum speed here, right? This is your stalling speed. Now, in option A, in option B, and option D, what is the speed is given here? 17.36 means in option A, option B, and option D, the minimum speed given here, or you can say the lower possible, or you can say the options are given here are nothing but you can say lower than your 34 point how much 22, right? It means that what if you compare your B stall cannot be used, cannot be, or you can say your B minimum cannot be B minimum, just a minute, B minimum cannot be lower than the B stall, right? Please remember this one. Shall we write in this fashion? Hello?
Yes.
Am I audible or not? It means that what? Even if you know what is the elimination method, you can mark option C here, no doubt. Now, again, they're saying gross weight of an airplane is 7,000 Newton. Okay, W naught, W is given 7,000 Newton. Wing area is given capital S is 16 meters square. The maximum lift coefficient CL max is given 2 or 0.2. Assuming density at the altitude is 1.23, rho infinity is 1.23 here. The stalling speed, you can, it's a straightforward question. V stall equal to root of how much? 2W divided by how much? Rho infinity into S into CL max, right? Check please. Hello? Calculate how much you're getting. Your stalling speed here is how much? 2 into W is how much? W. What's the weight? 7,000, right? $7,000 divided by how much? Rho infinity. It's a 1.23. Okay. What is the capital S here? It's a 16. And what is the CL max? Prabhuji, what's the value of CL max? It's a 2, right? So just simplify it and let me know how much you're getting.
18.8597.
18.8597.
How much?
18.8597.
8597. What? Gadya Gode? Obviously, meter per second, right? Please take care of the units also. So how much we are getting? Yeah, up to 2 decimal places, right? So you can write it's 18.86 meter per second. So it's within the range, right? Okay, next question. An airplane is in steady level flight with a true air speed of 50 meter per second. The ambient air density and ambient pressure at flight altitude are 0.91 kg per meter cube and 7 into 10 to the 4 Newton per meter square. Sorry, yeah. Respectively, at sea level, air density is 1.225 kg per meter cube and ambient pressure is 1.01 into 10 to the 5 Pascal. The equivalent or indicated airspeed of the airplane is, it's a very straightforward question, right? What do you know? You know, B true is equal to equivalent airspeed divided by relative root of this relative density. So what is given here? They are saying the true airspeed BT is given 50 meters per second, right? Check. Now, the density at sea level is given how much? 1 point. Tell me how much it is given? 1.225 kg per meter cube.
Yes, sir.
Right? 10. Any other thing? Yeah.
Yes, sir.
At what altitude it is given? At sea level? Okay. An airplane is steadily with a true speed if the ambient air density and ambient pressure at the flight altitude are okay. So the altitude is unknown. It is flying at some unknown altitude where you can say the speed here Vt is given 50 meter per second. Definitely you have to write these all things. Now the density at this altitude h here rho h is given how much? Can you tell me? 0.91 tt per meter cube. Simran, are you getting? Hello, the previous approach. Simran,
Yes,
did you get? It's a very straightforward. You can calculate minimum speed and you can take the comparison. So rho h is how much? 0.91. So sigma is nothing but rho h upon rho sl. Consider what is this root sigma, which is nothing but a root of how much? Rho h upon rho sl. So root sigma is equal to how much? 0.91 divided by 1.225. Tell me how much you're getting.
0.861.
So you can write. Okay, what is this root sigma value directly? Can you tell me those?
0.8618.
8618.
0.8618, right?
18. Yes, sir.
What is the unit of this? Huh? What is the unit? Yes. What is the unit? Very good.
Dimension.
कल ही तुम्हें यूनिवर्सिटी में हम बताते आके फिर BT is equal to how much? Tell me. Yes, please. BE divided by root of sigma, right? So BT is equal to B value is how much? Tell me.
50.
50.
50.
50,
Very
sir.
good, huh? 8618. Can you tell me what is this value those? BT?
58.01.
So 58.018.
होगा. So V
Something is
find
wrong.
करना है.
Sir,
Sorry.
V फाइंड आउट करना है, VT given है.
Sorry. Yeah, BT is equal to BE upon root sigma, right? BT is known, so B is how much? B is nothing but you can see BT times of root sigma, right? Now correct?
Yes, sir. Yes, sir.
So B is equal to BT is 50 into root sigma is how much those?
0.8618.
0.8618. Can you tell me what is this value? BE?
43.09.
43.0945.
43.0
0945
945
458.
458.
So nearest value or up to 2 decimal places? What they're asking? Round up to 2 decimal places, right? So you can write B equal to 5, 9. Okay. So you can write it's a 43.10 meter per second. Are you getting this value?
Yes, sir.
Yes, sir.
What is the range of answer? It's a 43.05 to 43.115. Is that clear, Prabhu? Maharaj, take care of this. Yeah, the maximum thrust developed by the engine at sea level is very straightforward question. They are asking the aircraft is flying in a steady state and level flight under what condition? Under sea level conditions, right? Okay, the weight is given here, W is equal to the 10,000 kg, right? G value is given 10 meter per second square. So first of all, you can write W is equal to M into G, right? It's a mass, right? So you can write here, that's nothing what you can say, 10,000 Newton. Is that clear, Maharaj? Prabhuji? Devi, are you there? Yes.
Yes, sir.
Hello. Okay. Now, elliptical wing. Okay, elliptical wing means U is equal to 1. Wing span is given how much? 10 meter. Okay, then any other data?
Sir,
Wing
area.
span area is given 30 meters square, right? Just take care of this. And then the CD naught for the aircraft is 0.025. So CD naught is given 0.025 here. Then the maximum speed of the aircraft in steady and level flight at sea level is 100 meter per second. Very good. So here B max is given 100 meter per second. Okay. The density of the density is given at sea level is given how much? 1.225 kg per meter cube. Okay. Now, what they're asking? Maximum thrust. So whenever it comes to the maximum speed, minimum speed, right? Or you can say maximum thrust, just use the Brahmas. What is our Brahmas here? In a steady state and level flight, your thrust is equal to drag, and this is nothing but you can say it's a summation of your parasite drag and yes, induced drag only, or simply you can write it's a AB square plus B upon B square. Say yes or no? Now, A is how much? 1/2 CD naught. And what is the value of B here? It's nothing but you can say KW square divided by 1/2 rho into S. Calculate what is A, what is B, right? And here put the value of B max, you will get what is the maximum thrust TA. Am I audible or not? Hello, am I audible to you? Calculate. Each and everything is in front of you. They are given these all data just you know to calculate the value of K. K is equal to how much? 1 upon pi EAR, right? Check. So what you can do here, aspect ratio is nothing but you can say B square by S, right? So tell me what is the aspect ratio of this being B is equal to 10. 10 square means 100. 100 divided by how much? Am I audible to you? Hello?
Yes, sir. 100 divided by 30.
S is how much? 30, right? So how much you're getting? Aspect ratio is 3.33 something?
Yes, sir. 3.33.
Yes, sir.
Sure. Okay. Put these values here. Okay, calculate key value. So key value is how much? 1 upon pi is 1 because it's an elliptical being plane form. Aspect ratio is 3.333, right? Calculate. What's the value of K? Can you tell me?
0.095. 0.09549,392.
Just wait.
0.09549,392.
29?
49, sir. 49. After
49.
9549.
Okay.
No,
You can
no,
take
sir.
up to
0.095.
just wait. कोई और बोलना?
49.
0.0955888.
Yes. 0.0. Yes, please.
9558.
हमारा ना दिमाग खराब हो चुका है, तरीके से बोल। 0.0 हेलो,
0.0955.
just a minute, okay, just a minute. Battery is gone. Just a minute, huh? Let me put this camera. या हाँ दोस्त, कितना आ रहा है तेरा, बताना जरा। K इक्वल टू
0.95502
0.0
955
हम्म
02
हम्म
510.
Okay, leave it. You can write up to 4 decimal places, so you can write 0.0955, right? Check. Am I audible? Hello?
Yes,
Calculate
sir.
what is the value of capital A and capital B and let me know. Make it fast. You're getting late. Tomorrow at 9:30 you are having this full length mock test, right? मैच गए थे आप लोग या नहीं खाना खाने के लिए? क्यों राम, पार्षद,
Yes,
जो भी
sir.
बच्चे हॉस्टल में रह रहे हैं?
यस सर।
वेरी गुड, ठीक है। कैंटीन तो खुला रहता होगा ना नाइट में?
9 बजे तक फिर।
क्यों मेडिकल वो मेडिकल साइड में नहीं खुलता है?
वो सर सब
और वहाँ पे सिर्फ चाय
चाय
मिलती
मिलती
है।
है।
अच्छा,
10 बजे पी के आते हैं।
बोलो तो परमिशन करवा दें। हाँ बताओ।
अब
सारी
सर
रात
10 दिन के लिए कर।
बिना परमिशन जा रहे हैं।
आप लोग बोला करो, ऐसे काम मत किया करो, बिना परमिशन वाले काम नहीं। ओके बोलो, यूनिवर्सिटी अपनी है, आपकी है मतलब। ओके, तो 0.0955। Are you getting this value? Please let me know what's the value of A and what's the value of B. Yes, please. How much you are getting? खुशी, are you there?
So, वो b स्क्वायर भी मल्टीप्लाई किया है, वो वैल्यू बोलूं?
नहीं, मुझे A की वैल्यू चाहिए और B की वैल्यू चाहिए। B तो सबको पता ही है, राइट? You can put the value of B. It is given, right? How much it is given? It's 100. Tell me separately what is the value of A and what is the value of B, so you can put here directly and you can write.
Sir, A is 0.459375.
0.45
93
93
75.
75, right? Into B square. So B is 100. So you can write here it's 100 square, right? Plus B is how much? Capital B. What's the value of capital B, Prabhu?
51.
Sir,
5
51972789.
कोई भी एक स्टूडेंट। यस
51
51
97
97
27
27
89.12.
89.12 divided by how much? B square. So it's 100 square, right? Now calculate. Bata. Yes, how much you are getting? Please let me know first.
9790.646.
9790.646
90.646 Newton. 6 Newton.
Newton or kilonewton?
Newton.
Sure.
Yes, sir.
We are getting 9790, right? Okay. Okay, so the limit is given here 9780 to 9795. It means that our calculation is good. Sorry, our calculation is correct here, right? Hello? Your accuracy is quite good. Just few more questions. Yes. Again. what they are asking, the maximum cruise speed is, so क्या करेगा? Directly you have to write Vmax is equal to how much? Yes, anyone? T plus root of how much? T square minus 4ab. Check please. Hello? Simran, are you
Yes, sir.
there? Hello, Simran, are you there? देख ऐसे नहीं चलेगा क्लास में, साइलेंट होके मत बैठ बेटा. इज इट क्लियर? देख जितना ज्यादा बोलेगी उतना बेटर रहेगा, कॉन्फिडेंस आता है. चल बता मुझे कितना आ रहा है. T plus root of t square minus 4ab divided by 2a or a only? It's a 2a, right? Check. Tell me how much you're getting. Calculate what is the value of a and what is the value of b. You know, in these questions, just only you have to calculate what is the value of capital A and capital B and just apply this formula. Yes, am I audible? Can you tell me what's the value of capital A and capital B here? Again, you have to calculate. It's a 1 by 2 rho S CD naught. B is how much? It's a TW square divided by how much? 1 by 2 rho into S, right? Please let me know how much you're getting.
Sir, A is equal to 0.1125.
Just a minute, I'm having some messages from management. Yeah, tell me how much you're getting?
0.1125.
0.1125. Very good.
And B is equal to 7 times 1.
7 times 1.
Yes, sir.
1, 1, 1, 1, 1, 1, 1. Like this.
Yes, sir. 0.11.
Are you sure?
Yes, sir.
Okay. Please verify this value. Yeah, you are correct. Correct. A is 0.1125 and capital B is 7 times 1.11 only. Yeah, correct. Now here, just put in this formula and let me know how much you're getting.
$87.1, sir.
How much?
87.1 meter per second.
Please verify.
Yes, sir. 87.1.
Are you sure? Confirm है? लिख दूं मैं? $87 point. Yes. Answer is 87 point. Yes, tell me. 1041. Yeah. 1041 meter per second, right? Okay, let's check what is the range here. So they are saying up to the nearest integer. So what is the nearest integer? If suppose these decimal points are, you can say it's something like this. Let's say it's at 87.1041. So up to 1 decimal point, what you can write? It's 87.1. If suppose this digit is lower than 5, right? Then generally we have to neglect. So here, this is nothing what you can say. 87 is the correct answer. That's the nearest integer value. Nearest integer. Right? Check. सिमरन एक क्वेश्चन कराऊं क्या इसी को?
Yes, sir.
प्लीज. अभी तो रेंज एंड एंड्योरेंस के क्वेश्चंस बाकी हैं यार. ओके. सेकंड अप्रोच करना है क्या? हेलो. सेकंड मेथड चल जाने दे. यस. I will share in group. Okay, don't panic. The second approach also. Shivam, are you there? Shivam Gupta. Hello, Shivam, Ajay, are you there? No. Okay, I will ask them to means send you the other solutions to in the group. Okay, means you can calculate easily with the help of this formula. B max is equal to root of 2TA divided by rho s into CD minimum. That's it. Just you will get answer, or you can say the time taken by this method as well as by this B max is equal to root of t plus the root of t square minus 4ab divided by 2a. It's quite same. Okay. So
सर
what
क्वेश्चन में CD नॉट दिया हुआ है, CD मिनिमम तो दिया नहीं हुआ.
You have to calculate CD minimum. You will get two value of the CD. One is CD minimum. That's what I'm saying now. ये आपको कोई नहीं पढ़ाता है, ठीक है? CD minimum and CD max value.
ये कैसे सर? ये मतलब
मैं भेजता
कंडीशंस
हूँ आपको. नहीं, कंडीशंस नहीं है, जस्ट आ जाता है करके. मैं बताता हूँ आपको. मैं सॉल्यूशन शेयर कर दूँ आपके साथ अभी.
चलेगा सर,
Personally?
सब चलेगा.
ठीक है, कुछ भी नहीं है, बहुत इजी स्टेप्स हैं. सी बच्चे क्या सोचते हैं कि दिस CD minimum condition, okay, and CD MD both are same value, but these two values are not same. The CD MD is, you can say it's a drag coefficient value corresponds to the minimum drag condition, or you can say minimum thrust required condition, or you can say it's a corresponds to maximum LYD ratio, or you can say CL upon CD ratio. Is that clear, Maharaj ji? Hello.
Yes,
and the CD minimum is different. The CD minimum corresponds to, you know, Vmax value. Am I audible?
yes,
The
sir.
CD minimum value corresponds to Vmax. Even if you look at this carefully, okay, if you look at this carefully, it is satisfying the condition. Your Vmax is proportional to, you can say, root of TA, right? Second one, altitude effect is what? Vmax is proportional to 1 upon root of what? Rho infinity, or you can say rho, which is nothing but you can say it is directly or indirectly. Indirectly, it is representing what? It is representing altitude. Look, am I audible or not? And this TA, that's nothing but you can say thrust available, or you can say T max, and it is the function of, you can say, capacity of your power plant, capacity of aircraft engine or power plant. That's it. कुछ भी नहीं है एरोस्पेस में. तुम लोग ऐसे ही मतलब बोझ लेके घूम रहे हो. आ रही बात समझ में? 4 साल पढ़ा नहीं, दिक्कत ये है ना. इफ यू लुक एट, कहीं और मत जाओ, इसी क्लास में देख लो ना. यू कैन लुक योर बैचमेट्स. Maisha, third year student, when he was in 6th semester, when she was in 6th semester, she secured all India rank 17. Third year, it's not a fake result. 17th ranker, okay, third year student, it's a record. Not a single coaching wala has been secured such rank in third year. 17th rank, third year student. You can cross check. Mahisha, Paran University, PU. Then 37th rank. Again, it's a third year student from SVIT Vasad. That's Jeet Prajapati. And many students, I think 7 to 8 students have qualified from the third year class only. And then another rank, I think it's a 155. Pawan, what is your rank in third year? 155?
Yes, sir.
Yeah, it's a third year from PU only. So इंजीनियरिंग को है ना 4 साल में खत्म करो. थर्ड ईयर में या सेकंड ईयर से गेट की प्रिपरेशन स्टार्ट करो. बीटेक को ना पंचवर्षीय योजना मत बनाओ तुम लोग. लेट मी क्लियर. बट पढ़ना किसको है? बस सब कुछ तो करवा रहे हो आप लोग हमसे. यूनिवर्सिटी में भी पढ़ाओ, फिर इधर भी आके पढ़ाओ. पढ़ना है नहीं तो क्या करें? चलिए, तो shall we stop today? Hello, shall we stop? And yeah, though if somebody want to join the classes, you can contact me on my number here. These are my numbers. You can message me or call me. We are starting new batch from the last week of February. I will share the browser very soon. Okay, thank you all of you. Now you can leave.
Thank you.
सर
हाँ, yes please.
सर वो जो मैंने पहले क्वेश्चन पूछा था ना वो डिसेंट का,
मैं भेजता हूँ आपको, मैं आपको ड्रॉ करके भेजता हूँ अभी. ओके,
ओके सर,
मैं आपको ड्रॉ करके भेजता हूँ.
ओके सर, ठीक है.
और किसी को की डाउट? हेलो, एंड लिसन केयरफुली. हेलो, देख इस टाइम पे ना बहुत टेंशन होती है, ठीक है, और टेंशन में क्या है, वो पढ़ता नहीं है. सो बेस्ट चीज क्या है, आई हैव आस्क्ड ईच एंड एवरी स्टूडेंट्स ऑन 22nd of January, like next 14 days 14 hours per day, right? am I audible or not? 14 घंटे डेली पढ़ना है अगले 14 दिन तक. कब से मांगा था? 22nd और 23rd से. सो अगर आप उतना फॉलो कर रहे हैं, nobody can beat you, it's a guarantee. My blessings are always with my students. ओके, अब इसको ब्लेसिंग्स को चाहे तुम कुछ भी समझ लो, चाहे इसको ब्लेसिंग समझो, चाहे इसको पनिशमेंट समझो, राइट? इट्स योर चॉइस. या 14 घंटे सो, कोई दिक्कत नहीं है, फिर रोना, फिर रिजल्ट आएगा, फिर रोना बैठ के वहां पे 4 दिन, फिर वापस आना सूरत घूमने के लिए, है ना? इसलिए पढ़ ले, कुछ ना रखा लाइफ में, सब माया है, ब्रह्मा सत्यम जगत मिथ्या. यस, एनी अदर डाउट?
सर एक
Any other
क्वेश्चन था
doubt?
74 नंबर वाला.
इसी में?
हाँ सर, एपी में ही.
एक मिनट. हाँ, 74.
यस सर.
एक मिनट रुकना बेटा. 74 ना?
यस सर.
just wait. 74, right? 52, 74, 72. This one? Oh, it's a 75. And where is the 74? It's a missing. Okay, I will. We can discuss on phone. Okay, no issue.
सर मैं व्हाट्सएप करूँ आपको? वो सीजी वाला क्वेश्चन था, उसमें मोस्टली सबको डाउट आया था. आपने बोला था मैं बाद में करवाऊंगा, तब करवा दूंगा.
ठीक है, मैं भेजता हूँ उसको. ओके, बट इसमें तो क्या किया है बच्चे ने, उसने पीपीटी में आई थिंक कुछ हुआ, ठीक है. हाँ, कुछ चेंज हो गया है, सॉरी. 73 या कुछ आगे पीछे किया है, तो 75 becomes 72, 72 becomes 70, like that only. I have to check. Okay, I have to check it. Okay, मैं आपको पर्सनली भेजता हूँ. एनी अदर डाउट?
सर वो शायद नोज वाला क्वेश्चन पूछ रही है, लाइक भी
अच्छा,
जो जो
वो
मैंने
वाला
आपको भेजा था और आपने बताया नहीं था कि मैंने सही
पिछले.
किया है कि गलत किया है.
Okay, 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 okay. I will check soon. Okay. Having
Yes,
some
sir.
health issue, that's why I didn't check it.
सर वो एक बार
Okay.
ग्रुप में डाल दे तो आप देख लेना.
ठीक है, मैं देखता हूँ एक बार.
यस सर.
अभी मोबाइल फोन मेरे पास नहीं है.
हाँ कोई दिक्कत